So when you are typing some commands, it might be some monitoring message, some message keep on pop up like this. What you can do is when you type in the command, some message pop up. You should press tab. Okay, just press tab. You don't press enter because you are keying some configurations, commands. You don't want to just simply press the enter to execute the command. It's very dangerous. So if you something pop up when you are typing your commands, you just press tab. And the tab will bring you to the next line. Okay. Here, like this. Somehow, if I type in the command, the message pop up. My cursor is now here. I just press tab. Okay, it's okay. So this is how you configure the host name for your router. So you always put for the network device name. For the best practice, we always configure in capital letter. Okay, capital letter, and then put some name, like meaningful name. Okay, so depends on, maybe you can put with locations or somehow, or if you do your documentation very well, you can just put R1, R2, or something else. Then inside your documentation, you will state, R1 is at which locations and which floor, something like that. So the names, you always should put something that easier for you to identify. Here, because of the label, we put R1. So here, we also put hostname as R1, so that we will not confuse with that. R2, we put R2. Okay. So next one, clock settings to set the time zone. Okay, for time setting is someone is a bit special because this we configure. This is to configure the time, but this configuration is done on user view. Okay, you can see here. This is pointing back at user view. So let's try to configure the time. So this is the command, clock time zone, clock date time. Okay, and the clock daylight saving time is the commands. So you also can refer to the command below. So we start with R1. So go back to user view. What you can do, you can just type quit, enter, or there's a shortcut key, still remember, Control Z. Okay, in the user view, clock, space, time zone, space. Okay, you can put any time, any, maybe Nigeria, space. Okay, from Nigeria, the time is +1. So you can just push plus, means add. Okay, okay. I erase this first. Okay, space. So what are the commands? If you forget the commands, so you can just press question mark, and then a list of commands you can use will be continue to in this command. It will be listed. So I will take add space. Okay, what else? Question mark. Time zone offsets. So I should start with 01 colon 00 colon 00 space. Anything else? Anything else? Just click on question mark. CR means just press enter to execute. Okay, so this method, this question mark, you may also use in other configurations when you're typing other commands in interface view or in protocol view. If you not sure what are the commands or what are the format you should like this. This is the time zone offset. This is the format you should follow. So if you're not sure about the format, okay, you can always use the question mark. So and then we can configure the date and time, clock, date, time, space. Okay. Then question mark. See all. You should specify the time by hour, minute, and seconds. So what's the time for now? Let's see. So time for now, you can just put hour 09 colon 22 minutes colon 00 second space question mark. Now you have to input the time, the date according to this format. Okay, year 2020 minus 07 minus 15. Okay, and then space question mark, or no more, CR, enter. Okay, and then you just display, okay, display clock, enter. You can see today is Wednesday, time zone Nigeria. There's UTC +1, and here the date 2020 07:15, time 9 hours 22 minutes. Okay. So these are just the how to configure the time zone and the date and clock. Okay. So next one, CLI header messages. So we can configure some header message. So we have two types of command: header login and header shells. So we can configure two types of header. So for header logins, you can set the header that is displayed on the terminal when a user is authenticated by a device. So what is this? This is before you log into the device. This is like a welcome message. So you can also refer at the example below. Header login information. Okay. Header login information. This is the command syntax. And then behind, you start with a double quote. Welcome to Huawei certifications. Or in your real device, you can just say, okay, welcome to welcome to this router. Okay. Then you close with a double quote. You start with double quote, close with double quotes. Okay, we try this one. So to configure this, you have to be inside the system view. So go to system view, SY tab, system view, header, login, information. Header login information, space, double quote. Okay, welcome to HCIA. Okay, RNS training. So you also always close with a double quote. Okay, you start with double quote, close with double quotes. Means the symbol. You start with what symbol, you end with what symbol. Okay, press enter. So this is the welcome message before you log in. And then header shell is what is a message. It's just like a warning message. After you log in, maybe you can pop out a warning message to tell the user to please don't reboot the device. Okay. So header shell, okay, information, space. You can always start with double quotes. So please, okay, don't just put please do not reboot. Okay, and then close with a double quotes. Then press enter. Okay. So that's it. So how to show this? Okay, what you can do is go back to user view, Ctrl Z, go back to user view, and then for user view type quit. User view type quit. Okay, press enter. You see, I quit means here I show that user interface con0 is available. Means I connected. Okay, back to using the console. So press enter. Please do not reboot. We can straight see the warning message because we doesn't need to log in. So we don't have the login session. So we cannot see the welcome message. Okay, it means that we don't have the authentication session. So we just go into the user view. So you will pop up. We will see this. Please do not reboot, the warning message. Header shell informations. Okay. So next, HCIA command levels. So user level. As I mentioned, in either in user view or system view, this is what you can what command you can do. So in user view, you can just display. In system view, you can do configurations. Okay, but we still can further separate it. Okay, means that different can further separate the user to different levels. That means user with different levels. Maybe they are allowed only to access the user view. Some of them might be given the privilege to access to system view. So here you can see user level 0. We have 15 level of users, user level 0. The command level means until what's your command, the privilege, what are the commands available for you to use at user level. If you are user level 0, is command level 0, and this level we name it visit level. Okay, just a visit. Maybe you can just ping or do some debugging, ping or threshold. The very limited function you can use in visit level. You cannot display the statistics of the device. So if you want to review to display check the statistics of the device, you can go into monitoring level, which is user level 1, and the command level you can use include 0, okay, and 1, okay. So that's a monitoring level. In monitoring level still, you cannot do any configurations. So you want to do configurations, you go into, you assign the user with the configuration level 2. So in this level, you can the command the user can use command from level 0, level 1, and level 2. For this, you can go into configuration level, is where you can access to system view command. So system view is a command for you to go into configurations, the interface to system view. That's the name of system view, where you can do the configurations. So further, after user level 2, we have user level 3 until 15. 3 until 15, if you don't configure anything, actually 2 and until 15, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is all same level. We also call the highest level, same level. So at this level, we call this management level. So the command level you can use either include command level 1, level 0, level 1, level 2, and also level 3. So what are the level 3 commands? Example. So it's a command that for you to doing file management. So the management here means file management. So doing file management allow you to check, to list out what are the files, what are the folders and files inside the network devices. So it's a very you need to be very careful with this management level, because these are the level that allow you to download, copy to do the file backup, the configuration file backups. And also, you can also need to be also in the management level to do the software upgrade, the VRP product version for the firmware upgrades. Okay, so it's very so depends on your the requirements, you should just assign the level according to the scope of what the user needs. So, for example, here go into system view, and then we have the command privilege level 3 view user safe. So, what is the meaning of this command is? So, you can just read from behind. So, there's a command called save. Save. This is the command save is to save all your configurations. So save. So how to read this? For save command in user view, because use save only can be run under user view. Okay. For save command in user view, we assign this to user level 3. Okay. Means that you need to have user level 3, then only you can use the save command in user view. So it means that maybe you are monitoring level or your configuration level, you cannot save the current running configurations. Okay. Next. So user interface. User interface means that what interface you can use to log into the network device. So in the network device, mostly very common. Actually, we just provide two types of interface. One is called the console. So you console, because you see the relative number is 0, means each time only allow one console user to log in because you only have one console port. Okay, because you only have one console port. So if you have to configure this console is local login. You have to go to on the spot of the switch of the network device so that you can use your console cable plug to your laptop, and then the other end plug to the network device in locally. So if you want to do remote login, so means that you doesn't need to be present right on the spot just to configure, to check the router or check the switch. You can use VTY, okay, virtual teletype interface. So this is where you can configure for telnet user and the SSH user. So by default is 0 until 4, means total 5 user is supported by default. So you can further extend this to 0 until 14, means maximum 15 telnet or SSH user connections. So if you don't do this, if you didn't configure the VTY, so you are not allowed to log into the network device. Okay, user view, interface VTY. Another one is user minus interface console. Okay, so next, so CI terminal attributes. So these are the 3.
Excuse me,
yes.
Can you go back
yes.
to the user interfaces again, please? Since this is practical, I think it should be a little bit slow.
Okay.
Sorry. Yeah. VTY. So.
Okay. How about we do some configuration here? We just continue here. So we stay in R1. So R1, press enter. If this is, you can see, if some as time passes, I will be being logged out, being kicked out from the sessions. So this is called the idle timeout. Later we also can see this. So now we go SY tab system view. Okay, we follow the command. User minus interface. User interface space VTY. So question mark space question mark. You can use 0 until 4 or 16 until 20. So I can just use 0 space. So the last 0 until 4. I can just configure this file all at once. Okay, VTY 04. So what else I can do? Because I want to configure VTY with 5 VTY sessions for user to log in. So I have to set because someone to log in, I have to set the passwords, means the authentication modes. So I type authentication. It's just type authent and then tab. Okay, to set your type authentication minus modes space question mark. What mode you can choose? AAA, none, and password. So by default is none. But just remember, if you want to do telnets and or the SSH, you must have the password so that you can be connected. So by default, there is the login is none. The authentication mode is none. No authentication method. But here you can choose the 2 options of the authentication. First one is AAA, AAA. This one we'll see maybe during next Monday. So now we can see this. Use this password. For AAA, you can have username and password. For password, you only have password, no username at all. So password space question mark. Okay, nothing. So just press enter. Authentication mode password. Okay, and then how to set the password here? You can press set space authentication space password. Okay, if you don't know the command, you can just press enter. Press the question mark, not enter. So set authentication, set space authentication space password space question mark. So cipher or simple. So cipher or simple means that after you key the command, the password will be saved inside the router 1 in R1 configurations, current configurations. So you should put something. If you put simple, your password will not be encrypted inside your configuration file. So you put cipher. So the configuration will be encrypted. So set authentication password cipher. Then what is the password you can put? Okay, what's the password you can put? Okay, let's put 123. Enter. Okay, 123 enter, and then you want to check what have you displayed. What you have configured on this display, on this user view, this VTY. You can always just display this DIS, or just type the same display. Okay, this HCIA. So under this this view, I have configure the user interface VTY 0-4, and then set the authentication password for cipher, password cipher, and then you see just now I put 123 here, but now it's all being encrypted, so it's much more secure than the plain text. So maximum number of, so maybe we can start to set some authentication modes. Okay, local, no, sorry, should be passwords. Okay. Enter, question mark. So nothing else, a password. Already put in the password. So I think that's all. So actually there are some more command you need to put. So VTY, okay, just quit from here. First Okay, so now you go back to system view, R2. Okay, already being passed to the expired the life, the ideal timeout. So I being kicked out. So I can just press enter to join back the command line CLI interface. So console is 0. VTY of the telnet is 0 until 4.
I won't do one meeting, sir. I don't.
Okay.
So, Mr. Richard, can you mount your volume? You're making call, mount your volume, you're disturbing the class.
No.
Mr. Richard, Obo Biafo, can you mount your volume?
Turn this faster. It's faster.
Okay. Okay, I can just help to mute it. Okay. So let's continue to this HCIA terminal attributes. So this is to configure some how the system interact with the user when he log in. So either timeout, you set a timeout duration for user connections. So either timeout means how much time to wait before I declare I assume there's no user on that particular interface, or no, is there's any user on that is logging in, or some actions have been made. If there are too much time, so we might have to set the timeout shorter. So depends. It actually depends on your operating management, operating system, operating and management O&M management. So anything you change here will not affect all the configurations inside the meeting. Okay, no, inside the configurations. So you can try the first one, either timeout. So by default is 10 minutes. So I can set the timeout duration of the user connections. So under this, still the same VTY. R1, we still under VTY. So you just put the history command max size, history. So you can just press tab on history. History command. This is what I want. So you can just try the last one. History command max size. So this means the history commands that you can press, it will be kept inside the system. Okay. So history command max size. How much? Maybe you can put it 20. Enter. Max size. Max size is a dash in between. Space, no space. Enter. So success. Mean that how many times I can press the up button. So I can press 1, 2, 3, 4, 5, 6, 7, 8. No, sorry. Again. So by default is 20. It's gone. Okay. Let me see again. Okay. So by default is you comment size is 10. Okay. By default is 10. Is it work? Yes. Is it work? History command max size 20. Yes, it works. So next one is the screen length. Screen length is how many lines to be shown displayed at once when you have a super long long result, just like this. Just press question mark. So got so long. So see, start from the user interface view commands. you count until return. By default, this is 25 lines. No, by default, it is 24 lines. 24 lines. So you press tab, press a space bar to show everything. Continue to show until finish. So again, you can use this command: screen length. Okay, screen length. Sorry, it's screen space length. Screen dash length. Screen length. Just put it by default is 24. Maybe I can just put 10. Before is 24. Okay. It's just 10. So again, question mark. This time. Oh, so now you haven't, because we are using the console to log in, not the VTY, not the telnet, so we won't see the effect here. So just press Ctrl+C if it doesn't wish to show the command below more. So another one is the idle timeout. Idle. Okay. And let's time up. Base question mark integer to the minutes. So you can have 9 minutes. So by default it's 10 minutes. Space second, how many seconds? You can just put 99 seconds. Then enter. Okay. Oops, because this is seconds. Seconds, I can put 0. Okay, means 99 minutes. For each console, for each this telnet login, the session will stay. If the system, if the console, the user stay idle for 99 minutes, it will be automatically kicked out. So next one, okay. User privilege, configure user level, set authentication password, change the authentication level password. So set the level on, okay, set the level on the VTY0 user interface to true. So system view, user interface VTY0. Okay, what are the user privilege? You can just use a user space privilege level 2, and then set authentication password as a cipher. So after this, press enter, you will see enter, please enter password. Huawei 123. So do the same thing. Now we are in this VTY 0.4. We're going to put the user privilege. Okay, user privilege, question mark level. Question mark. What do we have? Ideal timeout. Idle timeout. Okay. No. User privilege level space question mark 0 until 15. Actually, 0 until 15. You can just set it. So 0 until 15 means choose from here. Follow this label, this table. So I should just put the level 2. Okay, let's just try level 2. Sorry. Before that, you go to the R2. Can you try to ping your next? Ping R1, R2.
Take the slide to the user permission slide, please.
Sorry, what do you mean?
Could you go back to the user permission slide, please?
Okay, whether I have permission for what?
The permission slide, the slide. If you could go back to that slide.
Oh, the permission, okay.
Yeah, that's it. Thank you.
So user privilege level 2, so that you can do. You can do configurations. So now the next one, the set authentication password cipher. This is a difference because just now remember we already configured this. Okay, display this. We already set the authentication passwords to be cipher. So the behind here is the encrypted passwords. So okay, so go to the next one. So CR interface configuration. We can try to configure the interface. So now what are the interface that we connected here? So G0 and G0, G0 R1 and G0 R2. So we can go into the interface. You just can click on here, and then interface space G0/0/1. No, this is 0. Let's stick at 0. So now I'm inside the interface view. So I would like to put some IP address. So what is the IP address? So this is one network. So you can just put the IP address. This is the example I give. 192.0.0.something .0. This is the network address space. Should be let's put 24. 这个 what is subnet mask? So put this 24. So means that for R1. Port G0, my IP address should be 12.0.0.1 because it's R1. R2 should be .2. So IP space address space 12.0.0.1. Okay, space put in the subnet mask 24. Okay, done. So we're up for R1. So how to check whether you're configured correctly? You can always under this interface view, display this. You can just this DIS space this THIS. Enter. So you can know that under this interface view, I have configured the IP address 12.0.0.1, 255.255.255. That's why the system, VIP system, will help you to convert to this 255 format. Okay. It's the same thing. You go to R2. Go to R2 system view, also same. So interface space G000. IP address. So we should have 10.0.0. How much? No, sorry. 12.0.0.2 space 24. Okay, it's up. So now we try to quit. Go to user view. Let's Ctrl Z. Ping 12.0.0.1 means the router 1. So you should be success to ping. Okay. Next one is we can try to configure some loopback interface. Loopback interface is just a diagnostic interface, management interface. So it doesn't. So try. System view interface. 100p look. Okay, sorry, I should. So I'm R2, I'm saying R2. So interface loop 0. Okay, or you can just type a full one, loop backspace 0 also okay. So in here, you can put the IP address, at. Okay. IP address for this loopback. If loopback there's no ports in loopback, so the network address, the IP and the broadcast is all the same. So just put here this R2, I just put 2.2.2.2 space 24. No, because this is look back 32. Okay, how all the 22 bits are all is network bits of the network. So enter. Sorry, should be IP address. IP space address. So 2.2.2.2 space 32. So next one, also some quiz. So how many users are able to connect via the console interface at any given time? How many users? So how many users? It should be only one user, okay? Because you only have one console port. So and what is the state of the loopback interface 0 when the command loopback interface 0 is used? Okay, what is the state of the loopback? Okay, check the state of the loopback means to check the state of the interface. So I show you this command. You click from here. So display space IP space interface or INT or interface brief. BRIEF. Display IP interface brief. So you can see this. The G0 has R2 is configured with 12.0.0.2/24. Loopback is 2222/32. Okay, so is it up or down? Here is up. So I can just do create one more loopback to show you without configure anything. So I can just create loopback 1. So I should go to the display IP interface brief. Enter. You can see for loopback, even though there is no IP address, the physical and protocol also up because this is the virtual interface. Okay, it's up. So do you able to follow until here, until this stage, this moment? So are you able? Okay. So if you're able to follow, let's see next one. So let's see the next topic. Okay. File system navigation. Just now we are already started to navigating from user view, system view, interface view. Okay, and then we done some configuration by configuring the IP address. Now we want to do the file system navigation and management. We want to check what are the file and the folders inside the network devices. As for example, in this simulator is the router. So let's see. So some forward. The file system represents the underlying platform on which VIP operates where system files are stored within the physical storage device of the product. So the capability to navigate and manage this file system is necessary to ensure effective management of the configuration file. VIP software upgrades and ensure that the physical device contained within each product are well maintained. So here what we can know from this forward is the configuration files and the VIP software upgrades, or the VIP system software. The image file and the configuration file is stored in the physical storage of the device. Okay, so in this section, I will show you how to navigate the device file system. And we also can manipulate the file system files and folders. So, and we will manage hallway router and switch storage devices. Okay, for the last one, I think it's just a review. So let's see. So viewing the file system. Why there's a file system inside the? Do I mean there's a file system like your PC? Yeah, in your PC you have the C drive, D drive, all these. So same. A network device is also still like a PC, like a computer, like a computer. The router or switch, they have their own CPU fan, motherboard, random access memory, and the RAM. So the storage, either it can be flash or it can be a SD card, the micro SD card. Okay, because for router, for a router, we provide the options to use the micro SD card to transfer files, or to store the files. So viewing the file system, change directory, okay, is to change directory to which directory, to parent directory or to some children directory. And then how to view current directory, okay, PWD, this is to tell you where you are now, which folder you are in now. So, and then dir, the third command, dir is to view the content of the directory. Okay, you have one folder. Folder means directory. So in here we just say directory. In one directory, you have many files and folders. So you want to check what are they. So you can just use type the dir, enter, you can see. So, and then how to view a file content, use more. So if there is a text file, you can use more. Because this is CLI. CLI cannot read, cannot open the picture file. So this is what you need to be careful with. So view file content. So next one. How about we do something of this? Okay, same. Go open your R2, still R2, and just now we configure R1. So R2, press enter. So to do file system navigation, you should be in user view. Okay, press Ctrl Z. Ctrl Z, shortcut key back to user view. So you can use where are you now? PWD, enter. Now your location now. You are inside Flash. So inside Flash, what file and what folders and files you have? dir, enter. Yes, I have the folder, or we call directories. Attribute start with D dash D. So all the attributes start with D means that this and are the folder, are the directory. Without the D, it's a dash. It's a file, not a folder. File with an extension. Okay, this is .txt. So can I read that? So and just use a more private data .txt.
Hello, Mr. B.
Yes.
It seems we need to mute all the mics. Something is interrupting someone.
Yes, I will mute the mics. Okay, let me mute all. Okay, good. So this is how you read the file, but you only can read words, text, because you cannot show picture on the using the CLI. Okay. So change directory. Change directory. You can just how many directory we have all this. Maybe I can try this DHCP. So CD space DHCP enter. Where are you now? PWD. I'm inside the flash slash DHCP. What do we have in DHCP? DIR. Oh, nothing in here. Is it that? Oh, there's a DHCP duid.txt file. Okay, next. So manipulating the file system part. So now we learn how to create folder, or we call that make directory, and also we can remove the directory. So follow me. So I can use mk. This is make mkdir. Okay. Create a folder. Folder maybe Huawei. So to check whether it is there, dir as a Huawei. Okay. Next one. So next command. So now I want you to move this folder. No, you cannot move folders actually. Okay, never mind. Just leave the Huawei folder here. Now I want you to go back to the flash. Okay, just use cd space dot means dot means back to your current folder. So
Sorry,
PWD. Yes.
Sorry, Mr. B.
Yes, please.
Okay, so I can see your directory there saying flash full column DHCP. Is it because you've set the router as DHCP?
No, I changed my directory. I go into the DHCP folder.
Okay.
Yeah. So now here I PWD. This is to show that just now I put cd dot means go back to my parent folder. So for DHCP, the parent folder is flash. So I'm now PWD. This will show where I am now. Where am I now? I mean flash. So I can use dir to check. So here I'm ready inside the flash. Okay. Okay. Here, please again mkdir space Huawei. So dir we check. Okay, the folder is created. Okay. So next, I want you to copy a file. Let's say copy a file. Which file do we have? Private data.txt. So you can use copy private data dash data.txt space. Copy this and then paste it where? If you don't state any the location, you will just paste back to the current directory. So you cannot have the same name. So you have to give a new name, maybe HCIA.txt, enter. Copy, yes. So copy file flash. Okay. So dir to try again. There's a HCIA.txt success. So now I want you to move this file HCIA.txt into the Huawei folder. So command move space HCIA.txt. So it's the case sensitive and everything. So let's follow exactly the same. So move into this. Oh no, move to where? Move space. Move to the folder. Okay, Huawei. Enter. Yes. dir again. Now can HCIA.txt is gone because now it's inside the folder Huawei. So I use cd Huawei. Enter to check where's my no, cd Huawei not inside the Huawei folder. I use dir. So I can see HCIA.txt here. So I can also do the rename. Let's do rename HCIA.txt to what? What's the new name?
HCIA. Check
Sorry, sorry. HCIA.txt. Then a new name, let's put the that. Okay, that.txt. Whatever. Okay, and yes. Then dir again. Yes, now change to lab.txt. Okay, so cd cd space dot back to the flash dir. Now I have this Huawei. Okay, now I want you to delete this Huawei directory. So the command is remove rm for remove dir space Huawei. Remove this directory. Okay. So I try to press enter. Remove directory flash. Yes, it should be failed. Error, directory is not empty. Okay, so in VRP, you can in network device in the VRP in this CLI, you cannot delete a folder which is not empty. So for now, so I have to delete the folder inside the Huawei first. So cd Huawei back to the folder, dir, you need that.txt, you put delete. So the file name that.txt. Why is it? According to this command, okay, delete. Just delete is to delete and then put into the recycle bin. So you just delete. If you put delete space / unreserved means permanent delete. So I just delete that.txt. Just enter. Delete flash. Yes. So delete succeeded. Dir is empty. File can't be found in the directory. So that's it.
Excuse me, I have a question.
Yes.
Now, if you have a directory with, say, 50 files, are you going to delete them one by one?
Yeah, no. You also can delete all at once. There's such command. Okay, let me. Okay, before I go to that, let's continue this first. So now I already delete the lab.txt, but the file is actually just be moved to recycle bin. You also consider deleted, but can I review what I had deleted under this folder? Maybe in future someone deleted the file, so you just know that someone deleted the file. You want to recover the file, but you don't know the file name. How to recover? So for recover is type undelete, and then the file. So what is the file name? I forget already. If you forget, you can use dir space /all. Okay, I can see, lab.txt with a square bracket. Square bracket means this lab.txt is inside the recycle bin. Then I know that I can undelete lab.txt. Undelete means recover, yes. dir again without the /all. Now lab.txt got no square brackets. But now I want to delete. Just do it permanent delete. So I can do delete space / unreserved. Okay. This string, or we can try this star.txt. Okay, enter. Yes. You see? How can I delete? Delete slash delete space slash unreservedly permanent delete all the asterisk star asterisk dot txt means that all the files end with dot txt will be deleted. Okay. So dir space slash all. Now no more. No file can be found anymore. So then I can cd space dot back to the parent directory dir and then remove dir rmdir Huawei. Enter, remove directory. Yes. So dir slash all. Nothing. You cannot see the Huawei folder anymore because I deleted it. Okay. So configuration file management system. Okay, so the current configuration load from the safe configuration if system flash memory at startup. So now R2. So what are the current configuration is running by R2? Can we check? Display or this? This is a shortcut key. There's a shortcut for display. If you press tab, it will show you display. Okay, display, current configuration, current, CURR, then press tab. So display current configurations. And so this is, so there's a more, press spacebar, says spacebar, show everything. So after this command, enter, start from this hash, everything. Okay, maybe he will tell you, okay, under the interface loopback 0, you configure this. Under the interface G0, you configure this. Okay, so these are the current configurations. This current configuration is safe inside the memory. It's what are running now, running by your running by the router. Okay, but so if what you configure, if you don't save, if you reboot, then the current configuration is gone. So now we want to save the current configuration into a safe configuration. So S2, you just press. Before that, you see dir. There's only 5 items at here. 4 folder, 1 text file. So save, under user view, save, enter, press yes, enter, press Y, enter. So please, okay. Enter. Now save the current configuration to the slot settings. Save the configuration successfully. Okay. Now dir again. You can see this. vrpcfg.zip. Okay, so this is the default name of the safe configuration of Huawei network device of this router and switch. So you can see. So means that this vrp.cfg is saved inside the flash. This is what we have done. So if you turn off the router, this will gone because this is a RAM. RAM doesn't permanently store a file. So but you already save the safe configuration file inside the flash. So that's now I use just now we dir, we display, we dir to check the flash, we see this. Okay. So now, when the system, when your device is boot up, you see it. So when your device boot up, since this is empty, so
Mr. Bay?
yes,
Sorry, after this save, are you saving with an extension? Because I can't see that file, the zip in my directory.
you can see the file. Just press enter. If I continue, are you sure to continue? You already put Y, right?
Yeah. After saying Y, it's saying
Yes, here, just press enter.
Yeah.
It
Sorry,
says,
there was an error. Hello?
yes, is there an error?
Yeah, after the enter, it was saying error, invalid file name or invalid extension. .cfg.
Oh, okay. So you try to save again. SAVE. Okay, enter. Are you sure to continue? Y, enter. Click
Save.
enter. Yes, save, enter.
Yes.
Y, enter. And then, do you see this? Now saving the current configuration. Do you see this?
Yeah. Okay. So double save. Yeah. Okay, that makes sense.
Okay. Okay, now you need to be in user view to save. User view, not system view. Okay. So if dir, you can see this. vrpcfg.zip.
Yeah, it's okay. I've seen it. I just saved
Oh.
once and I entered yes once. That was why. So it's twice. Now it's okay.
Okay, good. So continue from here. So every time your device is boot up, since this is empty, okay, so your device will take this configuration file, load into the RAM, become a current configuration file. So whatever when the device when the router is running, whatever configuration we done, we type the configuration, enter, configure the IP address, enter, configure user interface, enter, all the steps and command we done is done on the current configuration file. Okay, current configuration file. So that's why every time we do every configuration, we have to press, put the save command, enter, so that we can save all what we have done into the save configuration file. Okay. Next, so you can view your configuration files by display current configuration, what you have done, and display save configuration file. So this is two different files. So because after you load the save configuration file into the RAM, then you do some configuration on the current configuration. Means that both these both the files are different. The content is different already. If you don't do any configurations at all after the system is boot up, maybe current configuration and save will be the same. So saving the configuration file, that's
Please, can you go back to the slide again, please?
This one.
Yes, thank you.
So you can just display save, press tab, you can see. Here. So save, just now I show you what is this. So next, display startup parameter. Okay, just do it, just do it and see what we have. Display startup, enter. So what I have at here is startup system software is now next startup system software is so now because this is a simulator. We don't have the image and the actual image in the simulator here. So startup save configuration file now. Next startup Okay. We can use back the example and the slide. So display startup is to tell you configure where this is the, let's look at this startup system software. Okay. These are the currently working running image in the device. Okay, these are the VIP image running currently. They are 2220.cc. Okay, and then next startup system software. If you want to change, let's say you want to upgrade to a new version of the image of the system image, you can use a command. Later I'll show you the command. So after that, it will show it here. So startup saves configuration file. When this will tell you your device boot up is load. After your device boot is load, which configuration file, save configuration file it loads. Load from the flash. This one. So this one will show you the next one. If the device reboots, he will use this config. He will load this configuration file into the RAM. So if there's no accident, if no changes, so now you see I have next startup save configuration file because this is because I use the save command, but my current startup save configuration file is empty because this is the first time I start up I start up the router, so there's no file before that. So this now. So just now we already saved. So if you reboot the router, I believe you will see this. See this flash VRT-CFG.zip on this position here, entries. So now continue the next one. You can change startup save configuration flash / Huawei.zip. So we try to do this. Now it's flash VRT-CFG.zip. So we try to change this dir. So I try to copy the VRT-CFG.zip. Copy VRT-CFG.zip to a new name Huawei.zip. Enter. Copy. Yes. Done. dir. Yes. Then I got the Huawei.zip. So start up. So put a command. Start up. Save. Tab. Okay. Start up. Oh, okay. Wrong command. Start up. Save. Configurations. Huawei.zip. Enter. Succeed is setting the configuration file for booting system. Then I use the display startup. Again, the command to check. Now you see, next startup says configuration file flash Huawei.zip. So what is the in what scenario we can apply this? Okay, you see, if your from day to day, if your router or switch is running, it's working fine. And from day to day, you also will back up the configuration file. Okay, backup. You back up the file into your file server. Okay, file server, and then somehow one day your switch, okay, your switch is down. Your switch is spoiled, hardware failure. So you are being forced to change a new switch. Okay, what you can do is you buy a new one, the same model, same switch. You buy a new one, and then you can copy the. So you buy a new one, then you start up. You start up. So because this is the first time the switch startup says there's no safe configuration inside the switch. So after the switch is start up, can use a console to connect in and then configure some IP address so that you can connect to the network and copy some files. Copy the configuration file you previously already backed up in your file server. Copy Okay, download into the new switch, and then you use this command, startup safe configuration, your backup file, the configuration file you backup, maybe Huawei.zip, and then you reboot. After reboot, everything will be the same. Okay. So next one. So compare configurations, as I mentioned. Your current configurations might be different with your safe configurations. So you can use this command, compare configurations, to compare what are the difference. So compare configuration, enter. So because they are the same, the current configuration is the same as the next startup configuration file. Nothing changed. So next one. So let's say you want to change a new switch, another new switch. Your switch is working fine, but you want to upgrade. So the old switch, you want to erase the configurations. So you can use this command, reset save configurations. Okay. Reset save configuration, enter. Yes. So again, display startup. Enter it. So now next startup save configuration file is now nothing. Means that next time after this, you put this command, you reboot your switch or reboot your router. Then the router will, because there's no save configuration anymore, so the router will boot with using the factory setting. Okay, factory setting. So it means that it will become just a new switch, come out from the factory. Okay, so that's all. Next, so storage device types. In Huawei switch, Huawei routers, we have this SD RAM. This is just a RAM like the laptop RAM, a short RAM. Okay, short one. The same like the laptop. And then we have flash. What you can see just now, the flash memory, and then non-volatile RAM, NVRAM. And then the SD card, we are using the micro SD inside, because inside the AR router, we have this SD card, micro SD card. This is the card same with as what you put in your phone. And then you can use USB port to plug in your thumb drive, okay, to transfer the file. Okay. So you can use a display version. Let's try this command, display version. Display version. Okay, you can check monitor, configure system software, nothing. Okay, here, should be here, sorry. Display version, Huawei versatile routing platform software. Okay, Huawei VRP software, version 5. Okay, this is version 5, means the VRP 5. And then behind here, it will show something because this is ENSP. So this is the product version. Okay, product version. Based on the product versions, if you met some issues, so you need to find some guidance to configure. You need to know what the commands can be used and how to use. You can always go check the headers. The headers. So how to check is because there are many versions in the document in the product documentations. So you use this and you inside your device. You use this display version and you check the product version. You follow the product version. You download the product documentation. Follow with the same product versions. Then next one, erasing storage device. You also can, just like the PC, you can format the flash, or format the SD cards. You also can fix this, the flash, fix the SD cards. But this depends on the product features. Some new router new products might not support this command. So these are depends. Okay. So what does the D in the DRWX attribute of the file system represent?
Can you allow us to see the last two slides, please?
This one?
The last two of them, yes. This and the
Okay. So what does the D means? D means the object is a directory, a folder. Yes. So this question also will be asked in the exam. It's a very easy question if you remember this directory. So how can the configuration file store within the file system? Again?
Sorry, my network was broken.
Sorry, again? I didn't hear you. Okay, there's a photo.
First question, what does the D in the DRM?
So it means the directory. Directory. DIR. This one means this is a directory folder. If you don't have D, means this is a file. Okay. How can a configuration file stored within the file system of a device be implemented for use by device? Just now I already told you, you copy you download a new configuration file and then save into the router. So you want the router to reboot and then use the new configuration file. These are the commands. Right, start up, save configuration, and then put the file name.
Yeah,
and then yes.
Sorry,
Yes.
if you're done, I just want to know, when I type the display version, I'm not seeing the various storage devices. I'm just seeing it displaying me some.
Yes, you won't see that. You won't see that.
Right. Okay.
Because this is a simulator.
Okay, that's fine.
In real device, you will see that. Okay. So will you have any chance to access to the real device? So you can try, if you any chance you can access the real device, you can try all these commands. So I see there's an error posted in the WhatsApp group. Let me see. I'm ready to review from the second storm. Okay. These maybe first you can try to check the help here, the help, ENSP help. See if there are any related issue. Performance counted. Performance counted. Okay. How about we take a 10 minutes break first, 10 minutes break. Okay, now, so break, 10 minutes. So continue at
I'll make it 10:55, please.
55, okay. Okay.
Ais. Ais. Ehilebo Ehime. Are you there?
Hello, good morning, Lucky and Bubu.
How are you doing? Hello. How are you there?
Fine.
Okay. Why no one answer? Imafa. Hello. Yeah. Sir?
Mine is greeting
Oh,
Mr. Salami.
okay. You do well though.
Do you have the exam to write this one?
The
Focus on the exam and write this. Okay? Lucky.
sir,
Go and focus on the exam and write the exam. I'm giving you also the exam issue for students. Please.
I'm not going to talk at the same time.
Hi, buddy now.
Thank God they improve small. But
I'll
I
be
never
doing
get I do on drug. Never get strength at all.
After you don't get the WhatsApp link.
I did inside the group when they create now.
That's
Not be that group when they not be the group when they add us.
I'm not sure it's not that one.
That's another special one day.
The what of what the Facebook link? I'm just going to give a Facebook link.
No, I'm not doing to Facebook link.
Okay. We'll discuss. Maybe after the training now, we'll discuss with Mr. Ben.
Okay. Thank you.
What you did? Day after the day for Google.
No, as I do. When this guy called me on this thing on video call yesterday, and told me about he see me when I did on the Zoom. I never strong at all.
I hope that okay.
You are strong in Jesus' name.
Amen. Oh, thank you.
Okay, so let's continue. So we are still in this is the last topic of the VRP. So it's called the VRP, Operating System Image Management. So VRP Operating System Image is the file extension is the .cc. Okay, so effective network administration and management within the enterprise network relies on all devices maintaining backup files in the event of system failure or other event that may result in loss of important systems, files, and data. So remote server that use the file transfer protocol FTP service are often used to ensure files are maintained for backup and retrieval purposes as and when needed. The means for establishing communication with such application service is introduced in these actions. So in this section, we'll talk about how the router, how the switch, how the network devices can interact with a FTP server in terms to backup their configuration file by upload to the server, or you want to download the new file, new server, or you want to upload the log file, or even you want to download a new system image in order to do upgrades. Okay, so I will explain the importance of maintaining up-to-date versions of VRP, and then we're establishing a client relationship with an FTP server. We can do this and simulate this FTP server in the ENSP, and then we successfully upgrade a VRP system image. This cannot be done because this is a simulator. Okay. So upgrading the VRP image. So new version upgrades may sometimes be required for what? To support new features and updates to the VRP. So according to different updates, maybe they try to fix some bugs or try to include new features or try to change some, or try to optimize some commands. Okay, so the Huawei might roll out a new versions, a new product versions. But the best practice is if the device is running fine, okay, we don't likely to upgrade the VRP versions because it might cause some errors if you doesn't familiar with that. Okay, so that actually depends if whether you need the new features or not. If you don't need, then you don't upgrade, because when you're doing upgrades, your device is being restart, is being reboot, so means your network is down, means all the device that connected to that all the end devices, all the clients that connect to the device will be disconnected from the network. So you need to plan very well. Maybe you need to plan a downtime if you plan to upgrade the VRP versions. So file transfer. File transfer may be used to retrieve VRP image files, as well as backup log file and configuration file. So router can be configured as a FTP client, and you connect to the FTP server using IP address. Then you can download the new VRP image file, or you can upload the log file and the configuration file. Then next, these are the file transfer methods. You can use FTP, which is using TCP connections. You will set up a three-way handshake. Okay, and then, or you also can use TFTP. Okay, TFTP is using UDP. There's no connections that need to be established before start to send the data. Okay, so next time we see VRP upgrade process. So the first step is you must make sure your router have an IP address and you can ping FTP server. Means the connection between the router and the FTP server is working fine. After that, you have to check. Use your DIR to check how many bytes, how many size, how many space is free in your router. So you have to check whether, so that you can download you have enough space to download the VRP image file. So if the storage capacity is inadequate for image transfer, older image files can be removed using delete/unreserve. Okay, after you can ping the file, the FTP server, you prepare enough free space, so you can in the router user view FTP space 10012, which is the FTP server IP address, and then you will start to set up the connections, TCP connections, and then you ask for username. Okay, username, and then the password, and then you have login to the FTP server. So in the FTP, when you have login, you can use dir command to check what are the available files and folders being assigned according to the username. Okay. Then you can use the get. Get means download. Get vrp.cc to start download the file, the VRP image. Or you also can use TFTP. You can you first also the same. You might make sure your router can ping the TFTP server. After that, you can use the command TFTP IP address get the file name.cc. Okay, VRP the file name.cc. You see it. In FTP, you need to key in the username and passwords. TFTP, you don't need, just key in the, here you want to just state that, oh, yeah, I want to use TFTP, and this is the server IP address, and get me this file, done. Okay. So it's very much more less commands need to be used if using TFTP, but FTP is more secure because you need to have the username and passwords. Okay, VIP boot management process. So after that, after you download the new image file, you use this command: start up system software. The file name, the image file name .cc, and then you can check display startup. Next, start up system software VIP.cc. After that, you can reboot, save your configuration. You maybe want to save or might not, and then yes. Okay, and continue. After the system reboots, the device reboot, then you can load with the new VIP image file. So some quiz here. What should be configured on the client in order to establish the connections with an FTP server? Okay, so you need to configure the IP address for the client, for the router, so that the client or the router can ping the FTP server. And how can a user confirm that changes to the startup software have taken effect after a reboot of the device? Oh, after you finish reboot the device, how to check? Is the upgrade successful or not? Where can you check? You use the display version. Command display version. Display version. And then you check the version and the product version. Okay, so that's all for the VRP, everything about the VRP. Okay, so after this, we're going to, actually before we go into other topics, a new module. The next module we're looking at is the switch. Okay, what the switch, how a switch behave, and how what are the technologies we can apply, like STP, spanning tree protocol, and the enhanced version of STP, which we call the RSTP, Rapid Spanning Tree Protocol. These are the three topics we'll see by today. So before that, let's do some exercise regarding the VRP. Okay, here I have prepared some exercise for you. Okay, please, you do some exercise to refresh your, to recap, as a recap, or to refresh your memory. Okay. So please start from the question 1. You can either paste the answer in the WhatsApp group, or you can unmute your mic. Okay. So. Okay, can you see the questions? Okay, so which of the following storage device is used to store the startup configuration file in the router? Select one answer.
Flash.
That's A.
Flash, correct.
A.
It's a very, yes, correct. Flash is a very direct answer. Question 2. Which of the following commands can be used to query OSPF configurations of a device?
That's A again.
Display current configurations is correct. Select one or more. It can be one answer, it can be more.
B.
Which one? D? D?
Or display this, I think D.
D, correct. Display this. Not only you can use in OSPF protocol view, you also can use the interface view. You have to check what are the configuration I have done. Okay, on this interface. Okay, next one. Which of the following information is displayed when an enter command is incomplete on the VRP? Select one answer.
C.
B.
Is C.
Is C. Let's see. Display. Just put the display. Enter. Incomplete command. Okay. Correct, huh? Okay. Question 4. On Huawei VRP platform, which of the following can be used to invoke the history command saved by the command line interface? Select one or more. Let's see, I type many commands. I want to refer back what command I have typed. I can press
C.
C.
Yes, I can press the upper cursor key. Correct. Select one or more answer. Is there any more answer here?
No.
Display. Okay. We can use up arrow key. Can I use Control P? Can. See? Control P. Control P. Also the same, works the same. Okay, Control P also works the same as the upper cursor key. But what about this? Control U. Is the U means up? No, not yet. Control U, nothing. Okay, nothing. Of course, it's not left, definitely not left cursor key. So B and C.
Control P and upper.
Yes. Next one. Okay. Which of the following statements is false? False about the preceding configuration. Actually, is about the following configuration. Okay. Doesn't matter. So system view. Okay, I go into the system view, user interface console 0. And this console 0, I grant him the user privilege level 15. Authentication mode passwords. And I set the authentication password as cipher Huawei 2012. Okay. Which is the false statement? Okay, select one answer.
Configuration is complete. Administrate panel login device.
Authentication mode password.
Which one?
False.
Authentication mode.
Is false.
User privilege level 15.
A.
Okay. A is a false statement. The password for logging into the device through the console port should be this Huawei 2012 only. The cipher is part of the command syntax. This is a
Exactly.
parameter. Okay.
Yeah.
Okay. Be careful with this. So after the configuration is complete, the administrator cannot remote log in the device to manage the device. Of course, this is configured for console, not for telnet. Of course, the administrator want to log in and manage the device through the console port. Correct? Those who log into the device through the console port has the highest level of user right. Yes, user privilege level 15. Correct.
15.
Good. Okay, next. An AR2200 router is required to be configured from scratch. Okay, what steps are needed to achieve this? Select one or more answer.
Router is required to configure.
D is one correct answer.
Which one?
D.
It's A, D, D.
Assign configuration file to the next start of clear the current configuration.
D is correct. A is correct. And C is also correct.
C
D
is
need
correct. C is correct. D?
you also.
D is
D
correct. A is
also.
correct.
I
A
don't
is
think
correct.
this is correct.
Hello?
Shouldn't be correct.
Hello?
Hello, yes.
Why
Okay.
reset? Why reset is saved configuration?
Yeah.
Reset the
think this
save
correct.
configuration means delete the save configuration. Okay.
Sabine,
Yes.
what is wrong with A? Because at the end of the day, we are starting with a new configuration. You can copy from another one and assign it to this new one at the next startup, isn't it?
See the first segment?
From scratch.
AR2200 is required to be reconfigured from scratch. Means
From
the
scratch.
router is running. There's a configuration inside the router. I want to reset everything to factory defaults.
Yeah.
So what should I do? I should
Yeah, I
just reset the save configuration file and then reboot the router.
Yeah, Mr. B.
No, sorry. The question says the router is required to be configured, not reconfigured. It's meant to be configured from scratch. So we're assuming it's new out of the box. If it says reconfigured, then we can say we want to reset the save configuration. But it said configured from scratch. So that means it's a new router out of the box.
Yeah, Mr. B.
Yes. Oh, this is how,
what you're saying,
how you.
what you're saying is also, it's making sense to me because if we're reconfiguring, we assume that we've copied the configuration file before. We can assign in another configuration file that we copied before at the next startup so that we configure with that one. But if it's from the scratch, then the assumption is that there was never any saved configuration. I mean, never any copied configuration before. So we're only setting and rebooting it, isn't it? So that we can configure it afresh, isn't it?
Okay. If that's what you mean is if the following your way to interpret the question is your answer should be assign and reboot. Correct.
Yeah.
A and C. But following what I interpret is the router is already running something configuration. I need to reset everything.
Yeah.
So following my interpretation, it should be reset the save configuration and reboot. Then everything was gone. Then I can do my configuration from scratch. Okay.
It's not from scratch if you are resetting. That's my own thought.
Yeah. So it depends on how you think.
So
Okay,
if I have a brand new
this.
router, do I have to reset it? That's the question.
You don't need to reset.
Okay.
Here, what I interpret this question is the router is running with some configurations. What you need to do so that it can be reset means the configuration can be gone away, everything, and then you can start from scratch.
But Mr. B, what of clear the current configuration then?
Why you don't clear the current configuration? Because when you reboot, the current configuration is gone.
Yeah.
Okay. Yeah. Okay.
So, but Mr. B.
Yes.
I think the way the question was framed can still be rewritten. For example, if you say an AR2200 router, which is currently running, is to be reconfigured from the scratch. That will make sense because it means it's currently running at the moment, but it needs to be reconfigured from the scratch. Otherwise, what the other colleague is saying is that if it's a new one, it's already reset. You're not resetting it all over again.
Yeah, you're right.
That is correct. The English of the question has to be changed.
Yeah, because this is what they will ask.
So I think that
the
configuration should just be changed to reconfigured.
Yeah, that makes sense. It's either you reconfigure it or the existing or the currently running AR220 router is to be configured from the scratch. That would make sense either way.
Configure from scratch. Or if I add one more opinion from here is the configure from scratch means we have to do the commands start from zero. Type the command, not just download a configuration file and just load it. No, you type.
It's okay, Mr. Bay. I think we understand what you mean.
Yeah. So it's actually mean how you look at these questions. Okay, from different angles.
We're only suggesting that the framing should actually not be misleading.
Yeah. The language, and the problem is at the language, the grammar.
Yes, Mr.
I think there is need for us to arrive at one answer. You should not do that we are using the option C and D, and at another time we are using option A and
C
and C. So let us
either A and C or means that
yes.
So this is also true. I can take this as a true.
Okay. That was what I said earlier, Mr. Bay, that if it's already an existing router, you may have copied the configuration before. So you can reassign the configuration at the next startup.
Yeah. Means that if I don't want the configuration file that I previously saved somewhere, I don't want that.
Yeah.
If I use back the same file, means that I don't configure from scratch anymore. I just use back the same. Yeah,
but if you're using the FTP server to copy the updated one, then still in the existing router, you can use that new upgraded file to upgrade at the next startup.
That's not configuring from scratch. That's more like copying. They said configure from scratch.
It's okay.
Can we move on to the next question, please?
Next question.
Okay. Sure. Okay, which of the following methods are supported by VRP to configure the router? Select one or more ports. What are the ports or what are the methods?
Follow method.
FTP is correct, D.
Is it?
Through the console
Through
port.
FTP.
A. Through telnet.
Through telnet.
Through FTP.
Are you sure? I have to do some to configure the router.
No.
Well, okay. How you can access the router, either console or telnet.
Okay. Yeah. So telnet and console. Yeah.
Yes, correct. So next one, during device setup, the device selects the VRP version file depends on the configuration saved in the what storage medium. Select one.
Flash memory.
Flash memory, correct. Okay. The administrator wish to change the name of the router. Under which view should the administrator be in order to achieve this? Under which view? So that I can do configurations to change the name of the router.
System view.
System view. Correct. in the VRP system, what are the functions of Control Z?
To return to the user view?
To return to the user view. Select one or more. Is there any other answer?
To exit the current view.
Exit from the current view.
C is correct as well.
C is correct as well. Is B correct?
B.
Yes.
Is B correct?
B, to exit.
Okay, let me show you. Where am I?
If you're in the system view, go to the system view there in the R2. Okay, let's do Control Z. Let's see.
Control Z. What is this? This is return to user view.
Yeah, but you're exiting from the current view too, from the R2.
We're also exiting from the current view.
Do you mean B and D is the same thing?
Pardon?
No, not always.
B
Not always,
and D is not always, means not 100% correct. If I'm in user view, I want to exit from current view. Control Z, okay? Same thing. If I use quit, exit from current view, yes. If I add system view, I use quit, exit from current view. Okay.
Okay.
Okay, it's quit. So exit from console view, no.
But it says one or more, Mr. Bay. That's the problem.
Yeah, one or more. There's two answers now.
It's okay.
Okay, be exactly. Okay, so the purpose is to return to user view. That's more accurate. Okay. Next, you can run the pwd and dir commands on the VRP to view file information in the current directory.
False.
Yeah, the keyword here.
What's PWD?
File information?
False.
File information.
It's false.
False.
It's only PWD. Right?
If only dir can do that.
Yeah, right. Yeah. Okay.
PW cannot. Okay.
So, Mr. Bay.
Yes.
PWD is for the directories, just to see the
To
directories.
show where are you now?
No.
Working directory.
Okay.
Oh, you are in Flash. Just like that. Where are you?
All right.
Flash.
Thank you. Yeah, thank you.
PWD means print working directory. So it prints
Yes,
where you are.
correct.
Okay.
Print working directory. Yes.
Right. Okay.
So on the VRP, which of the following commands is used to display the current interface configuration in the interface view? Select one answer.
B.
Display this. Display
Display this.
Where is this? Yeah.
I thought display int brief will give you the shortest version of this.
Are you sure? Let me show you. I just configure this. You remember? So display this. I can know that. Oh, under this, this is what the configuration I have done. Okay. What about this? Display IP interface brief. What is this? This is the status.
Okay.
After this is the output. After I apply the commands.
Okay. Thank you.
Okay. Next, refer to the command below. Which statements regarding the shown command are true? So system view, okay, then user interface console 0, and then history command max size 20. So select one or more answer. Select the true statement. So A, once configured, commands totaling up to 20 bytes can be saved in the buffer.
That's true.
Is it? The 20 means the
20 lines.
bytes?
20 lines. Yeah.
20 lines. So A is false.
Okay.
The default value of the history buffer is 5. No. The default is 10. The command should be configured in the user interface field. Configure should be configured in the user interface field. Yes, yeah, in the user interface view. Correct. Yeah.
Yeah.
The command is used to adjust the size of the history command buffer. True, huh? The size. How many lines?
Yeah, it's true.
Okay. Okay, next. So for project cutover, backup or adjustment of configuration files are not required during VRP upgrade because lost file can be found in the recycle bin.
That's false.
This is false. Yeah, yeah. Don't do any delete. How can the file is inside the recycle bin? Okay. So next one, refer to the configuration output. Which of the following statements are true? Okay. Command is reset save configuration. Okay. Warning: the action will be delete. Will delete the save configuration in the device. The configuration will erase to reconfigure. Continue. Okay. A user should enter Y when wishing to clear the save configuration file.
A is correct.
That's correct.
B, the save
Save
configuration will be deleted after typing N. False.
That's
The
not
save
correct.
configuration file will be replaced with the current configuration.
Not correct.
No, so false. So last one, the save configuration file that the device starts with can be erased.
I think there's only one answer in this one.
Again, the save configuration file that the device starts with can be erased.
Yes, D.
Yes.
Yes. Okay. When an network engineer enter a command, the following information is displayed. Error: unrecognized command found at this position. So what is the error means? Unrecognized means the which one?
A, B.
Select one answer.
B.
B.
Then B, incomplete. Okay, at this position.
Unrecognized command. Let me do something. Okay. Hey. Unrecognized command means
The answer is D.
is it?
No such command. No such command exists.
No keyword is found.
Yeah. No keyword.
Unrecognized command. When the router is powered on, the router reads the configuration file saved in the default save directory to get itself initialized. Okay. If the configuration file does not exist in the default save directory, what does the router use to initialize itself?
Default parameters.
Is correct. Default parameters. Next, you can run the startup save configuration backup.cfg command on the user interface of the VRP to specify the backup.cfg file as the configuration file for next startup. True. Okay, very straightforward answer. Which of the following commands can switch a view from system view to the user view? Select one answer.
A.
System view to user view.
A.
Quit. That has to quit. Correct. On the CLI AR routers, the role of the save command is to save the current system time.
False.
False.
False. When the delete VRP CFG.zip command is run on the user interface of the VRP, the file can be permanently deleted only after it is cleared from the recycle bin.
True.
True.
It's true.
Okay, correct. Refer to the command output. What is the result of the shown command?
Pardon?
What's the result of the shown command? Okay. System view, command privilege level 3, view user save. Okay, this is inside the slide. I read. You can read from behind. Okay. The command adjusts the save command. Okay, now it's B and D. Yeah? Save command. Okay. Either in the of a user or in the user.
A saves it.
C.
Adjust
the privilege level. C.
Save command.
C.
C.
Yes.
Any other answer?
Perfect. There's a view. Okay, there's a view there. Sorry. A.
Nope. Okay, the answer is the command adjusts the save command in the user view to privilege level 3.
Yeah.
Okay.
Yeah.
The construction is a bit confusing there, really.
Yeah, actually it is. Okay, next one. On VRP, the command lines are classified into 4 levels in increasing priority. Visiting,
No, sorry,
visit
Mr.
level.
I'm
Yes.
sorry, please, could you please explain why
Yeah.
it is D?
Okay, what does this command mean?
Yeah.
Okay. This means that in user view, under user view, there is a command called save. Correct. Correct.
Okay.
And then you need to have the level 3. Then only you can run the command in user view. Run the save command in user view. If you are level 0, level 1, level 2, even you are in user view, you cannot run the save command.
Yeah, but Mr. B, I thought this says and there's a save there. Are we saying the save automatically understands that?
Do you mean this save is save current configurations?
Oh, okay.
No, no.
Okay.
You want to save, you are should be in user view and save one keyword only.
Okay.
Sorry, please, can we try it on the CLI, please?
Can
we illustrate on CLI?
Sure.
Level 3.
Okay, this is should be system view. Okay, command privilege level 3 view user save. Or I don't want to put the save first. Question mark. Oh, there's nothing.
Okay.
View
user.
User interface, user group, user template. Save.
So
there's no such command.
There's no such command.
Okay, but don't worry. I can just open the slide and we just copy from the slide. Okay, navigating. See now. Yes. Let's try to see how we answer this.
Command privilege up there. Yeah. The same thing here.
Level 3 is management level. Okay.
Okay, here. The given example demonstrates how a command privilege can be set, can change. Well, in this case, the save command found under the user view requires a command level of 3 before the command can be used.
Okay.
Okay. And then go back to here. The command adjusts a save command in the user view to privilege level 3.
Okay.
Okay.
Okay, I understand.
Okay, then go to the next question. On PRP, the command lines are classified into 4 levels in increasing priority: visiting level, monitoring level, configuration level, and management level. At which level the operator is permitted to configure service, but is not permitted to operate the file system? Select one answer. I can configure, but I cannot do the file navigating. D.
Configuration level.
Correct.
Correct.
Yes. Okay. Next one. Oh, super big. Okay. The following shows a command output on a device. Which of the following statements are true? Select one or more answer. Okay. The device name is Huawei.
Yeah.
Correct. Okay. Based on the bracket here. The standby main control card of the device is running properly.
Standby main.
Main control card is the standby main control card is of the device running properly. Main control card. Is it?
It shows quantity, right?
Is there any standby main control card?
There's no indicator.
Wait, this MPU 0, master, uptime, 1 minute.
And it's correct.
Correct, okay.
The standby main control card.
Yes, it's running properly.
So it's
Correct.
Which one is the standby main control card, please?
That means the
I don't see
standby
anything.
MPU.
Okay.
Main control card means the MPU.
MPU. It should be responsible for uptime and all those things.
So do you see any standby? I will just see the master.
It has been running for 1 minute.
That's, yeah, just run for 1 minute, yes?
Yes, that's correct.
So means that, is there any standby or there's only master only?
I don't see
From
any
here,
standby main
you don't see any
control card.
standby, so this is false. So next one, the device has been running for 1 minute, correct?
Yes.
That's correct.
The VRP version of the device is VRP5.
Please move it up a little bit. I can't see the last option.
Okay.
VIP5.
Yes.
Yes,
correct.
VRP software version 5.130.
Yes, correct.
Okay. The following shows a command output on a device. Which of the following statements are true? Okay, we'll start from the first one. The MAC address of the interface is
correct.
0E0 FC224F. Correct. the MTU value of the interface is 1000. MTU.
Correct. Yes, correct.
Maximum transmit unit 1000. The working rate of the interface is 1 gigabit per second.
Yes.
Yes, it's here. 1000.
Yes.
The IP address of the interface is 10.0.12.2/24. Correct. Internet address.
Correct.
They all correct. So which of the following is a full name of VRP?
A.
A. Versatile routing platform.
Protocol.
Yeah, not protocol, platform. Okay. ABCD, CD is under here. Which of the following command lines view exists on the VRP? ABCD. Which one? Select one.
All of them.
All of them. Correct. Yeah. The administrator wish to update the configuration file of an AR2200 router using a USB cable. How can this be achieved? Select one or more. The administrator should connect the USB cable between the terminal and the USB port of the AR2200 router. Is it true?
I think it has both the mini USB and the.
Yeah, so this wrong.
I think C.
C. Should connect a USB cable between the terminal and the mini USB port of the router. Correct.
Right.
Any other answer? One or more, or just one?
You can install the driver.
Install the driver. Correct. Okay, that's all. Okay, that's all for the questions in VRP. Okay. So for VRP, only in the exam only 3 questions. Maybe you will see three questions from here will be appear in the exam. Might be. Okay. Okay. So enough for VRP. Now we go into the new module, which is the establishing a single switch network. So now, single switch network means, well, we're just talking about layer 2. We're not yet going to layer 3, no routing yet. We just inside one network. Okay, what is happening inside one network? How the switch behave, and what are the technologies we can apply in this in one network, single network. So the introduction of a switching device as a part of the enterprise network demonstrates how networks are able to expand beyond point-to-point connections and share network in which collisions may occur. Okay. The behavior of the enterprise switch when introduced to the local area network is detailed along with your understanding of the handling of unicast and broadcast type of frames. To demonstrate how switch enable network to overcome the performance of obstacle of a shared network means that we use the switch to overcome the issue or the problem that may occur if we in the shared network. Okay, in shared network, so remember in shared network we are using half duplex, coaxial cable, or you can use a hub. So what happened is, in shared network, there are always collisions happen. So in order to overcome the issue, the problem, we introduce the switch. So switch, as you know, with switch, the port can run in full duplex, means two-way simultaneously. So there's no more collisions. The switch also separate, also means the switch separate the connection domain. But and then the switch also can handle the unicast frame in unicast way, unicast forwarding. Switch also can broadcast the broadcast frame. This is different from the share network, because in share network, regardless you are unicast, multicast, or broadcast, everything is being broadcast by in a share network. Switch is more intelligent. But so in this topic, we'll learn how switch do that. How switch differentiate. Oh, this is unicast frame. I should forward only to one host. Or this is multicast. I should forward to one just that group of hosts. So this is broadcast. I should forward to everyone. Okay, but in this IA level, we just learn about unicast and broadcast. So for multicast, we will learn in the IP level. Okay. So upon completion of this section, okay, you'll be able to, or I will explain in the decision-making process of a link layer switch, L2 switch. We're not talking about VLAN yet. Okay. So, and we can try to configure parameters for negotiation or link layers or for the L2 switch, but these configurations cannot be done. Cannot be done. So we don't do that. I also can later also explain you in real network, in live production network, we also don't configure this. Okay, the negotiation. Later we'll check. Later we'll see what is it. So the most important is you must understand the decision-making process of a switch. Okay, so building a switch, a single switch network, single switch, one switch. If there's one switch, okay, again, switch operate within the scope of the data link layer. So this statement is also an answer for one of the questions in the exam. Okay, layer 2 switch, okay, switch in layer 2. Okay, data link layer. Remember this statement. So there's a switch with 3 ports, G1, G2, G3, connect to 3 hosts. Host A, G1, host B, G2, host C, G3. And then each of these hosts have their IP address, 10.1.1, 10.1.1.2, 10.1.1.3 means, again, this is layer 2 switch, means everyone is the same broadcast domain, same network. That's why you can see the network address also the same, is 10.1.1.0. And then they have their own unique MAC address, 01234 AA, 01234 BB, 01234 CC. Okay, next. Okay, what is this? It's called MAC address table. Okay, so all switch will have a MAC address table. Or every switch, all switch will have and must have. If not, there's not a switch anymore. Okay, all switch have a MAC address table. What's the purpose? Is this of the table is to record the MAC address and the corresponding interface. What does it mean? Okay, look at the example. Each switch use a MAC table for making forwarding decision. Or I see. The purpose of the MAC address table is to help the switch to decide the forwarding, how to forward the frame. But how? Now the table is empty. How the switch fill up the table? I see. Now, host A, we like to, host A is sending a VRP and ARP request. So maybe the example here is host A try to send an ARP request looking for host C MAC address. So but here, so ARP request is a broadcast frame. So destination MAC address, broadcast. Source MAC address, host A MAC address, AA. So send to switch A. Switch A receive this frame. Switch A check the source MAC address is AA. Sent by this is sent by AA from what port? The switch A received at port G1. So switch A record Okay, AA coming in from G1. Okay, correct or not? Coming in from G1. Okay, means that switch A knows that, oh, if next time I want to forward data to AA, means that I know that I can reach host A at port G1. Okay. So receive. So the switch, I look at the switch, then the switcher auto record, you check the destination MAC address, FF, broadcast. So he will broadcast to all ports, all active ports, except the ports that he received the frame from. So if you do notice, the switcher, this L2 switcher, never change anything on the frame, not touching anything at all. Okay, just read the source and destination MAC address only, not changing anything. Because this is not routing. Because if the router route from one network to another network, the router will change the MAC addresses. But this is just inside the network. The switch don't change anything. So for broadcast, then the host C receive this. Host C will reply with a ARP reply, which is a unicast. Unicast with a source MAC address of CC. Host C, CC, destination MAC address AA. So this is the unicast. This is sent to switch A. Then switch A receive this frame, he will check it. Source MAC address CC, I record coming in from port G3, I record G3. Okay, then I check 0, 1, 2, 3, 4. The destination MAC address AA. Do I know AA? How can I decide? Okay, I check my MAC address table. I know AA. AA is at port G1. Oh, then I know that if I want to forward this frame to AA, I forward out to port G1. Through port G1. Okay, forward. Then the frame will go to host A. Okay, so now you know. Now you can see how the switch use the MAC address table to make the forwarding decision. So next one, this is the basic configuration of a port, or the switch ports. So you can go to system view, go into interface view. Example is port G1, undo negotiation auto. Okay, but means by default the negotiation is auto. But negotiation about what? About the duplex mode. Either is full duplex or half duplex. And then also you can the speed. The speed. Either it can be 10, 100 or 1000. Okay. So the example is it undo the negotiation auto and then force it to use full duplex only, and the speed is 100. So then you
sorry,
Mr.
Yes.
Because what's
Yes.
the auto speed?
Auto speed?
Uh,
What do you mean? Undo negotiation.
What's the default?
What's the default speed? Okay.
Yes.
By default, if you don't do any configuration, what is the default speed?
Yes. Yes.
As fast as it can. Depends. Let's say if on the switch can support 10, 100, 1000. If the host means the PC, the port on the PC also can support 10, 100, 1000. So which one do you think they will use? They'll use the fastest, 1000.
Okay.
Let's say
okay.
If the host only can support 10 and 100, of course, the switch also have to compatible, match the speed, hundreds. So this is, that's why by default, the switch can auto-negotiate. Okay, based on the both sides actually on the host also is negotiate, auto-negotiate. Both sides negotiate to actually to take will use the fastest possible speed they can use. So both sides can 1000, of course, use the fastest one. But here, full duplex, speed 100, means that the switch enforce this duplex mode, full duplex mode, and speed 100. Means the host, even the host can support 1000, you also need to fall back to 100. So, but this is not what we want, right? Because this is not an optimized network. Okay, so these commands, you can just study this for learning purpose. You can see after you configure this, you display interface G1. You can see the speed is 100, duplex is full, negotiation is disabled. Okay, because maybe in the legacy switch in Huawei old models, you can configure this negotiation, undo negotiation auto. But in new switch, new models, you are not allowed to do this command anymore. Okay, no more. So because we prefer auto negotiate.
Okay.
Okay. So if a switch records the source MAC address of a host device on a port interface, and the physical connection of the host is then changed to another port interface on the switch, what action would the switch take?
What?
Let's say,
The switch would have to learn the new address.
let's say, example here. Now, switch A learns that host C is coming in at G3, correct? Then later, we unplug the G3, unplug from G3, plug into G4. And then the host C send a frame again. What the switch will do?
The switch would have to learn the new address and update the MAC table.
Update the MAC table means that
This will be
deleted. This will be deleted, and then the new record is CC-G4, correct? CC-G4. Because in the MAC address table, one MAC address can only map to one interface. Okay, one MAC address, one interface.
Mr. Bill.
Yes.
So at what point do we require a gratuitous ARP to be generated?
What requirement is when the host want to validate the IP address, whether the IP address is used by someone in the network, in the same network. I mean. Okay. The purpose of the ARP request at here, ARP reply, ARP request at here, actually doesn't. It's just actually it doesn't really mean. Only it doesn't mean that switch only can use the ARP request or ARP reply to learn MAC addresses. No, it just means that when there is a frame, either any frame, any kind of frame, whether it's for different purpose, anything sent by the host, the switch can always check the source MAC address on the frame and then do the record. Okay, it doesn't limit it to ARP only. Any frame, any packets. You can say any packets.
Sorry, my question, Mr. Bay.
Yes.
Is that when you send a gratuitous ARP, I thought the switch will learn that to provide the switch information regarding the MAC address of the host.
Also will, because the switch also will look at the source MAC address. Yes, correct. Yes. But the purpose of the detecting the IP conflict thing doesn't related to the switch. That's all. Okay. The switch just look at the MAC address. I do my record and I look at the destination MAC address. I just forward. I don't care what is the content. Okay.
Okay.
Okay. So these are the basic concept, but here I prepare some slides for you so that you can understand. have a better concept of the behavior of a switch. So just now we see that when the switch receives a frame with a broadcast in the destination MAC address is a broadcast FF. So he will broadcast to all ports. But what about this? See, this is a concept. You also have to know when the inside MAC address of the switch, there's a MAC address G1 and it's a static. For MAC address, type of MAC address in the MAC address table, we have 3 types: static, black hole, and dynamic. Later I will show you what is dynamic and black hole also. So static is manual configure. The switch doesn't learn it. It is manual configured by the administrator. So I can configure 0, 1, 2, 3, AA. I bind to G1. Static. And this static will not flush away when the switch is reboot, because this is a configuration being done. This is part of the configurations. Now, this switch with this MAC address table, you receive a frame. Source MAC address 0123 AA, destination MAC address 0123 BB, received from port G1. So what he will do? Switch will check the source MAC address 0123 AA. I check my MAC address table. Oh, AA G1. I don't need to update anything. I don't need to do anything. And then I check the destination MAC address 0123 BB. Where is BB? I check my MAC address table. There's no BB. There's no BB. I don't know where is BB. So the behavior of the switch is broadcast, or we call it floods the frame. Flood the frames through all ports, except the port it receives the frame. I receive from G1, I will never forward back to G1. I forward to all other ports. If I doesn't recognize the destination MAC address. Sometimes people will talk that, oh, I doesn't recognize, I just discard it. No. The switch behavior is, I doesn't recognize the destination MAC address, I broadcast, or actually we call it floods. So, next. This one. Same thing, same frame. But this time, the MAC address table have still the same 0123 AA G1 static. Now 0123 BB G2 dynamic means that the switch has the switch self learn the MAC address BB at port G2. Means that there's a frame source from BB coming in at G2. So this is dynamic. This dynamic is not static. Means that this dynamic will be flushed away when the switch reboot. So this time, source MAC AA, destination MAC BB, the switch receive check source MAC AA coming in G1, AA G1 static. It's fine. Destination MAC BB. Check. Do I know BB? Yes, I know BB. This time I know BB. Who is BB already? So I forward to G2, up to G2 only. So this is unicast. The switch forwards the frame through port G2. If the switch doesn't recognize, flood broadcast. If the switch recognize, just forward out to that port only. Next one.
Sorry, Mr. B.
Yes.
So if the switch broadcasts and still cannot find the mark, the destination mark, what will happen to the frame?
Oh, actually the switch doesn't care. I just forward, done my job.
Okay.
If the frame doesn't reach the correct destination, means that all the device that receive the frame, discard everything.
Yeah,
So
okay.
what will happen? If the sender side is trying to ping, request timeout. Everything like that.
Thank you.
Okay. Or can even send out the ping request also. Okay. We can see this when your data, we also can demonstrate this also. That I show you. Okay, this one. After this, okay, next is the same. The first two record is the same, but now switch B, the switch receive a frame, source MAC address BB coming in at port G4. Okay, what happened? The switch look at the source. Okay, then you need to check BB. Do I know BB? Yes, I know BB. BB last time I know that BB is on G2, but this is dynamic. So dynamic means it can be updated, allowed to update. So this time BB coming in at G4. So I record BB G4, correct? Dynamic. And then I check the destination MAC address, AA. Do I know AA? I check. The first one, AA G1. Okay, unicast to G1. Okay, this can understand, huh? Means the can update. Okay, next. The switch receive a frame. Source MAC address, CC. Okay, and then record CC coming in at G4, dynamic. Okay, it's fine. Until here is fine. Huh? Then the switch check destination MAC address, BB. What happened? I check the MAC address table, BB, G4. Okay, so G4 I should forward out to G4, but according to the behavior of the switch, the switch receives a frame from this port coming in. The switch will never forward the same frame back to this out to this port, and if again, never. So the switch will discard the frame coming in. The switch discard the frame, not even go to G1, G2, or G3. No, the switch discard the frame. So switch discard the frame as switch cannot forward the frame through the same port it received the frame. So this is a very important behavior you must know, you must remember. Actually, all the slides I explained just now, this example, you must understand all this. Okay, next. Okay, any questions? No, if no, I continue. So this time, a switch with this MAC address table, the switch receive a frame. Source MAC address 0123AA. Okay. This time, the switch check. Do I know AA? Yes, I know AA. But according to my configuration, AA should come in from G1 because this is a static. Static means cannot update. Cannot update. This means that the administrator tell the switch, AA must come in at G1. Okay. So the switch see this. Now the source MAC AA coming in at G2 means that discard. Something wrong happened. Discard this frame. The 0123 AA is static bound to port G1. Switch discard all frames with source MAC address 0123 AA received at all ports except G1. If the frame is coming in at G1, so switch check a source MAC address G1 coming in. Okay, G1 correct. then the switch will check the destination MAC address to do the forwarding. But now it's AA coming at G2, so this is wrong. So the switch discard the frame. Okay, can understand this, because this is static. If like BB, like the situation here BB, because this is dynamic, it can be updated. Okay, but it's static, cannot update. So discard. Okay, then I continue to the next one. Let's see. Okay, this is the last one already. Okay, see, now it's solved. Black hole. Okay, this black hole is also manual configured by administrator, manual configure, and it's also that's why, as I mentioned, it's a manual configurations. So it will also remain in the MAC address table even after the switch is reboots. Okay. When the switch reboot, remember, when after the switch reboot, static and black hole remain. Dynamic, all gone. Okay. So what the purpose of black hole? When the switch receive a frame, okay, destination MAC address DD. Again, source MAC address AA, check. AA G1. Okay, no problem. Then check destination MAC address DD. Check DD. Where's DD? Oh, DD. DD is a black hole, means discard the frame. Don't care. If I saw DD, discard. Again, from another direction, I saw the source MAC address DD. Oh, it's DD. So I check. Do I know DD? Yes, DD. Black hole, discard. Okay. Means that 0, 1, 2, 3 DD is black hole. Switch discard all frames with source MAC address or destination MAC address 0, 1, 2, 3 DD received at all ports. I don't care. So switch don't care. When I receive a frame, I check. If I saw any DD, I discard the frame. Okay. So this is another behavior of a switch. Okay, according to different types of entry MAC address, static, black hole, dynamic. Okay, so what I explained in here, this slide, actually this include this is not in the training material. Okay, so I specially made this for you. Okay, you must understand this. Not only Huawei switch behave like this, all other switch, other vendor behave the same thing. Okay, this is a basic principle also of a behavior of a switch. Okay, that's all for the switch, how a switch behave. Then now we are going to a new topic. Let's see. Let's take a break first. Let's take a 10-minute breaks before we try to digest whatever I told you just now. So we try to digest, then because all the concept you learned just now will be applied into the next topic. You must be very clear of the concept.
Hello, Mr. Bay. Hello?
Yes.
Okay, hello.
Okay.
Sorry, Mr. Bay.
Yes.
What series are you using for the switch?
Okay. For this, I'm using S5700. But this you don't need to do this because I will share you this topology because I want our MAC address to be the same.
Okay.
I'll build this and then I will share you the topology.
Hello, Mr.
So
Bear.
PC1, yes.
Yeah, please, I want to confirm something.
Yes, please.
You said that, hello. You said if a switch does not recognize the destination address in AA, you said it broadcasts to all other ports except the destination, except the source port.
Yes, correct.
Then you said in DD, you said the switch receive at all ports, including the source address. Is that true?
Okay. Wait. The DD, receive at all ports.
Yes.
Discard. It means that the switch will got many ports, right? Receive the switch. If I need, regards to whatever port lah, any other port, the switch see the MAC address, DD. I don't care if it's a source MAC address or the destination MAC address. As long as I see the DD, I discard.
Okay. So it means that includes the source address.
Yes, I don't care. Coming G1, G2, G3, G4, don't care. Coming in from any port.
It's okay.
Yes. Oh, okay. I make a mistake here. Okay. Actually, you configure G as a black hole. There shouldn't be a port here. Sorry. Okay. Sorry.
Okay.
There shouldn't be a port. Okay. Should be like this.
So, Mr. Bay.
So it will be okay. Yes.
So in a way, you're saying you're just blacklisting the MAC address.
You are right.
Okay.
So I continue this. Okay. See, I configure the IP address of the PC, but I don't put the gateway because we just now we want to learn the technology we use inside the network only, inside one network. So we don't need the gateway yet. So PC connect to 3. Okay, I will save this. I should just start it first.
Are we to design the topology?
Yes. Okay.
We should go ahead and design the topology.
No, I will share you this because I want our MAC address to be the same because my switch MAC address, if you do it yourself, our switch MAC address will be different. So the result will be different also.
Okay.
Mr. Bear, please, the name of the switch.
5700.
Okay.
So this is the bridge ID. So I copy it here first, later I'll use this. Okay, I have shared the topology in the WhatsApp group. Please download the topology and open, and then start all the device.
Hello, Mr. Bay. Sorry, come again. I just lost connection.
Oh, I have just shared this topology in the WhatsApp group. Okay, please download
WhatsApp
the
group.
yes, okay. WhatsApp group. Yes, it's called stp.zip. So when you try to run the topology, your previous topology will be must be exit, might be turned off because ENSP only can run one topology at one time.
Yeah.
Mm-hmm. Oops.
Mr. Bay.
Yes.
It's a zip file.
It's a zip file.
Yeah, mine is showing me blank. I don't know. I can't see any topology in it.
Can't see any topology. Have you extract the file?
Pardon?
Have you extract the zip file?
Yeah, hold on.
You have to extract the zip file. Yes, if because Windows, you can just double click and go into the zip file. If you do like that, you will see the topology is empty. You have to extract first.
Okay, let me see. Okay, there we are. Yep, that's fine.
Okay, good. Okay. Before this. Okay, I'll just use this this topology as the teaching for teaching. Okay, so we don't care about the wording first, the label. Later I'll tell you what does it mean. So now let me do this. Okay, so let's say the MAC address table. MAC address table. MAC. Yeah. Okay, so this we have three switch here, S1, S2, S3. So each switch have its own MAC address table. Right. So what you want to do is how they learn. Okay. Now for PC1, my MAC address is 541111. Okay. Easier for you to differentiate if I change the MAC address to this. Okay. Okay, for now, yeah. Let's see. PC1 它有 ping PC2. So then PC1 will check the ARP cache table. Let's see. PC1 ARP cache table. ARP cache table. No, ARP minus A. Okay, nothing. Okay, nothing. So means that PC1 will send a broadcast frame. Correct. ARP requests a broadcast frame to look for PC2. So
sorry, Mr.
Again, yes, yes.
Are we to add those PC marks?
Oh, you mean the label here, this text.
Just the label of
this button. Click this text, this name text, and then you click on the canvas. It's just like a text box in the PowerPoint, in the Word PowerPoint actually. Just type what you want.
Yeah, I mean, do we write it? Do we?
Oh, you have to follow me a lot. No need, doesn't need. Later after I finish everything, I will still share this everything in the group for you. I also will upload to the Google Drive. Don't worry. Okay. So it's just for now. I do this for teaching purpose. Okay, but I still share you everything. Yeah. Okay. Okay, understand that this is the MAC address. So now PC want to send the ARP request, and the ARP request is a broadcast frame, source MAC address 541111. Okay, and then the destination MAC address FF broadcast. So G1, okay, S2, this is S2 receive the frame. What you will do? You will check. Correct. You will check. You will see. Let's see, let's put 11. 11. Okay. And then port G4. Okay. Okay, just put the short form if for easier to understand. One. So now then I check the destination manager is broadcast. So I forward. See, across. Forward. Flood, I mean the broadcast, floods. Correct? Okay. S1 receive. I record. Okay. Source MAC 1111. Port from G2. Okay, G2. And then for S3, okay, before that, after S1 record, then you check the destination MAC address. Is a broadcast. Broadcast, I forward to, not actually, I should say flood. I'm doing broadcast. Because I receive a G2, I cannot send back to G2. Then I only left one port, G3. So I flood out to G3. Okay, this is S1. For S3, I receive the frame. I also record 1111. Port G2. Okay. Right. Okay. Okay, now you see the issue is here. S3 received the frame. You also see destination MAC address FF. So forward flood to PC2, flood to S1. But you still remember, from S1, I already sent flood another one. The same frame, exactly the same frame. The switch never alter, change anything on the frame. Just look at the destination and forward. What happened? You can see the frame. The frame travel like this. And go to S1, go to S3. Okay. Now, remember S3. Let's see from S3 flood back to the S1. S1 receive. Then you check source MAC address 11. Okay, source MAC address 11. So do I know 11? Yes, 11. I know 11, but now 11 coming at port G3. So I update. Okay, I don't erase it first. Now 11 is at G3. This should be cross away. Okay, but I don't delete it first. I want to let you to see.
Sorry, I have a question.
Yes.
S3 received from S2.
Yes.
Broadcast.
Yes.
And then S3 also received from S1 broadcast.
Yes.
So I think S3 would have already learned S2 and S1 on his MAC table. I'm just trying to see the point of S3 sending a broadcast back to S1.
Okay. Yes. I'll explain one by one. Yes.
Okay.
Now I explain this direction for the S3 to S1 first. Okay. Receive. Then what we do? S1 receive this frame from G3. So we check the destination MAC address FF. Forward to this forward out, broadcast out to G2.
Yep.
Then S2 receive the frame at G1. You check the destination, the source MAC address 11. 11. Now 11 coming at port G1. So then I check S2 check the destination MAC address broadcast. Since the broadcast, I broadcast. Okay. Yeah. So
normally, I don't. You correct me if I'm wrong. Normally, when a switch is learning, and it has learned some addresses already, it normally doesn't resend the broadcast through the interface it has already learned. Is that not correct?
The switch receive a frame at the one, let's say S2 receive at G1, and then the S2 will never return that frame, send the frame back to G1.
Yes.
Yes.
Yeah. Okay.
But you see, if S2 has already learned S1 through G1, it would not resend. If it's sending another broadcast, it would not send via G1 anymore. It will now send through G3, I think. Normally, during the learning for the switch, that's how it works.
Okay, pardon, again. If S2 already learn
S1.
Learn S1, why learn S1? Learn the MAC address, isn't it?
Yes, of S1.
G1.
So already in its MAC table, S2 should already have PC1 and S1 on its MAC table.
Why S2 MAC table will have S1 MAC address? No, never.
S2, you see, S2 should have PC1's MAC address. You agree?
Yes, already here. 1. Yes.
S2 should have S1's MAC address from the broadcast is sent first, from the message you received from PC1. When PC1 sent a request, S2 would have learned PC1, then broadcasted through G1 and G3. So when it broadcasts through G1 and G3, at that point, it will learn S1.
G2 and G2 again.
Hey, why, you mean? I don't understand what, can you repeat again?
Broadcast message from PC1.
Okay.
Through S2.
PC1.
To S2.
To S2, coming in.
S2 sends a broadcast.
Send the broadcast.
Yes.
Broadcast. Okay.
Broadcast goes to S1 and S3.
S1, S3, okay.
Yes.
Yes.
S1 broadcast.
S1 broadcast.
Yes. So now S3 should already know the address for S2. Because that is the port it received the broadcast from.
Yes.
S3 already knows the address for S2.
Okay. What you mean here is S3 already received the frame from G2. So record 11 G2, correct?
Right?
Okay. Right. Correct.
And
You're
now,
right.
And now S3 now knows where S1 is.
S3 now knows where S1 is. S1 is
because S1 sent a broadcast.
Okay. Here, S1 also sent the broadcast. This time means that S3 need to update, correct? 1111 G1.
Yes. G1, sorry, G1, yeah.
Yes, sir.
Coming from S1, yeah, that's right.
Yes.
So
correct.
if PC2 sends a message to S3, there's no need for S3 to send a broadcast anymore.
No need. Because
S3 knows where
PC2 will
is,
send.
knows where S1 is.
Yes. Where PC1 is. S3 will know where PC1 is.
Yes.
Okay.
Precisely.
Yes, this is a unicast. It will be unicast. Because PC2 know the MAC address of PC1. You to put the MAC address of PC1 into the destination MAC address. Yes.
Yeah, so there's no need for a broadcast anymore. So it's just unicast.
Yes.
Yeah. Okay.
But now I haven't go to PC2 yet. Okay, you can see.
But we were populating the MAC address tables as though it was another broadcast that was going in the other direction. That's what I was checking.
Yes, you are right. Finally, you notice that. So, for one broadcast frame, it broadcasts into two different directions.
Yeah.
Let's say another. Okay. Look at the pink color. S2 broadcast to S3, S3 broadcast to PC2, S1. S1 receive the purple color one, and then broadcast. S2 receive the purple color, broadcast. Then broadcast. Broadcast. S3 receive again, broadcast. Broadcast. S1 receive, broadcast. Okay, so you can see that the frame is keep on being broadcast because frame do not have time to live.
That's a loop.
Yes.
You have created a loop.
The loop, yeah.
Yes, you see from the other direction. Blue color. S2 send to S1. S1 broadcast to S3. S3 broadcast. Broadcast. S2 receive. Broadcast. Broadcast. S1 receive. Broadcast. S3 receive.
Now I'm lost.
Broadcast. Broadcast. Okay.
I am very lost.
What do you think in this
It's
situation?
a loop. Like the loop system.
On two direction. Okay, on two
forever.
direction. Clockwise and anti-clockwise.
It should
and then
the network should converge somewhere.
I know until maybe you stop it, it will continue broadcasting. It's an endless loop.
Yes, it's endless loop. But is this the behavior of a switch? Is a switch do what is do, right? Okay, all right. What you learned just now?
Pardon?
Is a switch behave what he should behave, right?
No.
So
why not?
It's misbehaving. It's allowing broadcast all over the place.
Oh,
Yes,
I mean the switch
but it is still the same broadcast domain anyways.
Yeah, it's the same broadcast domain.
And there's no router.
Yeah, there's no router to start the broadcast at least. Because we have it's something like look like there are redundant parts. So it's just everything is just going. So we didn't put any parts on redundancy.
Yes.
Mr. B.
Yes.
The frame, I thought it's supposed to survive for a period of time.
The frame? Do you inside the Ethernet header? You only see the destination MAC address, source MAC address, Ether type, and the FCS. Do you see any timer, any time to leave, like the IP header? No. And the switch never read the IP header, so it's infinite for the broadcast.
Please, could you explain all the arrows? I need to understand.
Again, explain
all the arrows.
All the
blue arrow, the pink arrow, the red arrows. Yes. So, color by color, please.
The red color, okay. The PC one, red color is the very first ARP request sent by PC one.
Yes.
Which is the source?
Send to S2. S2 receive. They will you broadcast to S1. Broadcast to S3, correct or not? Only 2 ports. Okay. So S1 receive, let's say the blue color. It actually is mean the same thing. It's still the same broadcast, still the same frame. Okay, S1 receive at port G2. Okay, then he broadcast to out to this port G3. Broadcast to S3. Okay. At the same time, S2 before this, S2 also already broadcast the purple color one to S3 at G2. So means that S3, what did S3 do? S3 receive the frame from S1 and receive the frame from S2.
Yes,
Correct.
but
For two direction.
if we are looking at it logically now, S3 would have already received that frame from S2 before the frame from S1 came.
Correct. That's why S3 will first learn the MAC address of PC11 at G2. Next one is from G1. Yeah, keep on update.
Okay. Okay.
Okay.
Hello, Mr. Bear.
Yes.
Yeah, the blue color broadcast that came from S1.
Okay,
That came from
S1.
S1 to S3.
S3, yes.
It's supposed to get to PC2.
Correct now. Here is it, blue color. Broadcast to PC2.
But you did not indicate it with the arrow.
This one here, the bottom here, blue color.
The arrow below the
here.
No, the blue color indicated came from. I thought the blue color came from PC1.
No.
No, the blue color comes from S3.
S3
to PC2.
Okay, it came from S3. Okay.
Yes.
Okay.
It also came from S1.
S1. Okay.
Okay, it means the frame is traveling in blue color direction and also travel in purple color direction, two-way.
Okay.
Okay, so what happened is S1. S1 received the frame from two ports, G3, the G2 and G3. Yeah, G2 and G3. What is this? It should be G3. So it has to be G3. So means that S1 can update G2, G3, G2, G3. Correct or not? I receive from G2, I update. I receive from G3, I update. Update the MAC address 1111. Can update. S2 also the same. The very first one I receive at G4. Later I receive at G1, purple color G1, and then the blue color G3. Okay, then I keep on update from G1 and G3. I keep on update G1, G3, G1, G3. Update my non-stop. I keep on update my MAC address table. For S3, I receive at G2, purple color. I put in G2. Later, I also receive a blue color at G1. Then I receive again at G2. Then again at G1, G2, G2. I can update. Okay, non-stop update. Yeah? Yes.
So why is the switch updating what it already has?
Because I learned from new ports.
No. We already have S3, for example, having G2 and G1.
No. You remember this? When the switch learned the new, because I just didn't cross it out. I learned, I cross. If I next one, I learn from G2, I cross G2, then cross. Okay.
Okay.
So inside the MAC address table, one MAC address only can map to one port. Okay. So can you see the issue here? The switch does behave what he should do. I see broadcast.
Okay.
I receive a broadcast frame from one port. I broadcast to all the other ports. Correct.
Okay.
Even
so
though,
mean that
No. Hold on. Sorry. You broadcast to all the other ports that you have not learned yet. Not to all the other ports, because if you have learned
all
from
the other ports.
All.
I receive from one port, I broadcast to all other ports. This is what switch.
So that means the switch is acting as a hub now.
Again, the switch acts
as a hub. If it keeps broadcasting.
Yes.
Normally, if it has learned an address, it does not broadcast through that port again.
Okay, why? Now S1. If S1 learn from G, see I can say everything.
from G2.
From G2.
Come, Mr. B.
Yes.
So it looks
Okay,
like looks like it's a cycle, right?
Yes, it's a loop. It's a loop.
So if it's
cycle.
a loop, that means you have to isolate one of the parts and disable the parts so that no transmission will go through that part again. So you now form an acyclic path.
Yes. You mean I should just block?
You have to short one of the interfaces.
I have to shut down one of the link.
Yeah.
Okay. Maybe I should just shut down this also can. This also can. Either one, anyone, either one of the link. Or within either one of the port. This 6 port, between these 6 port, either one. I shut it down, and then there's no more redundant path.
So the idea is to identify the redundant path and shut it up.
Correct. You're right.
Or replace one of the devices with a router.
Oh, there will become a routing already. But now I just want network only. Why do you want to buy a router for layer 2?
Okay.
So this is an issue of a switch. When you interconnected the switch for redundancy, redundancy is okay, right? It's good. If one link down, I still got another path to go. But redundancy will cause loop. This is an issue right here. Redundancy will cause loop. So how can we stop the loop? Okay, I can just unplug. Okay, in this one, I can just unplug the cable. Can I do this?
Yeah.
Means that
yes.
That will make sense now.
I just unplug it.
No?
Okay.
Yeah.
I just unplug the cable and just put it aside beside the switch. I don't connect it.
Yeah.
Okay. But if the link down, if this link down, what happens? Oh, you just send somebody go back to the switch and then
you connect it back.
Yes, you just need to send someone physically go on site, connect the thing back. Connect the cable to the port.
You could instead of physically disconnecting it, you could administratively put the connection down.
Yes, you also can do that.
Yeah.
Okay.
So
I connect it back. Okay, so I just have to go to S3. Let's say S3 system view. What port is that? Interface G002. Shut down. Okay.
Yeah.
Good. Done. Okay. So, what is somehow this link down? What happened?
If that link is down?
Yes.
You administratively put up this other link.
Okay. But your administrator is sick. It cannot work. Oh.
You undo shutdown on G2 and G3, S2 and S3 connection.
Yeah, already shut down. And then one day this link suddenly break.
Depending when it to be fixed.
So you just have to ask the engineer, log in, telnet, remote log into the S3, and then put up undo shutdown.
Yeah.
Yeah. Okay. Okay, right. Good, huh? Okay, what happened is this is your engineer, where it is. Your engineer here. PC1 is your engineer. What happened? Can you remotely? This is already down. Yes.
Instead of disabling the link. Hello?
Hello, yes.
Instead of disabling or shutting down the path,
okay,
you could have separate ports configured on the switches. One to be an alternate port, another one to be a designated port, things like that. So that
you are coming to the answer.
Load balancing.
Yes, you mean that's what we will learn. SDP, shortest spanning tree protocol.
Spanning tree protocol.
That's what we going to learn. The technology we're going to learn in this topic. Okay, you see the loop. Okay, but I want redundancy. I want something that can logically or temporarily shut down or temporarily block one of the ports to cut off the redundancy, no redundancy. But when something happens, another link down, the technology will automatically enable the port again. So the administrator doesn't need to do anything. Yes, the technology is we call spanning tree protocol. It's a protocol to help you to block. If this, remember, this is the spanning tree protocol is a technology applied in layer 2 in one broadcast frame, in one broadcast domain, in one network. Okay. I heard some robot voice on me. Who is that?
Standing tree protocol.
Yeah, spanning tree protocol. STP. Okay, this one. Okay, let me capture data between switches. That's me S2. I capture S3. I'll let you see what happened. S3.
Where noise coming from?
You can see this is a spanning tree already running. It's protocol. I don't do anything yet. Okay, this spanning tree protocol is enabled by default in all switch. Okay, so enabled by default means one of the port is already being blocked. Let's see which one is it. It should be. Let's see. 6.2. Okay.
G2 and G3, S2 and S2.
The block, one of the port is already being blocked to stop the redundancy. So which
G3 on S2?
G3 on S2. No, this is this blue color is I do Wireshark capture.
Okay.
I capture the port. What is being sent in and out from the port, I capture.
Okay.
So the port being blocked is at S1G3. S1G3. This is the port being blocked. Let me check. So display STP.
Is STP brief?
No, brief should be brief. Display STP brief. Yes, it is. S1 G3 is discarding set, means it drop all the packet it received, everything it dropped. Okay. So this is what we're going to learn. A spanning tree protocol. So I let you see also. I also try to want to demonstrate the effect, the consequence of if there is no spanning tree protocol. S1 STP disabled. Yes. I disable the STP. STP disabled. Yes. For S3 also. STP disable. Yes. Okay, I have disabled all the spanning tree protocol in all the 3 switch. So now my PC1, I want to ping PC2. Ping 10.0.0.2. Okay. Destination host unreachable. Request timeout. Request timeout. What happened? Okay, let me see the Wireshark. What I captured. Can you see? Where is it? What is this?
Broadcast.
Who has 10.0.0.2 ARP request? You see, this is reply from the PC2. Key on reply. Okay, send.
So it's all broadcasting.
Yeah. See, how many seconds now since we
broadcast storm?
Yes, this is a broadcast storm. Just a few seconds since we disabled the STP. Now already, what is this? 18,000 frame is being created.
Oh, wow.
Okay. Then it won't stop. It's not stopping because frame got no time to live. It will be infinite flooding broadcast in the network.
Okay.
Yes, this is broadcast storm. What happened to the switch? The switch, some message is shown in the switch. MAC move detected. Flapping port G1 and G3. Flapping port G1 and G3. G1 and G3 flapping ports. What do you mean by this? I displayed. Just now I haven't show you the MAC address table yet, right? So here I show you display MAC address table. So this is 1.1. PC1 from G3. PC2 G3. Okay, I press up. I show again. 1.3. Again, 3.3. Again, 3.3. 1.1. 3.3. 3.3. 3.3. Again, it will change. 1.3. Later it will change to 1.1.
Wow.
Okay. 1.3. Keep on update, non-stop.
Yeah.
Same for S1 also. Display MAC address. 3.3. 3.3. 2.3. 3.2 to 2 because you only have 2 ports connected.
Yeah, it's updating actually.
Oops. Yeah. 2.3, 2.2, 3.2 like that. Okay. Same as S3. Okay, display MAC address. 1.4, 2.4, 2.4, 1.4, 1.4, 2.1, 2.4, 1.4, 2.2. Can we see 1.1? Go to okay, enough. This is
so let's enable
MAC address.
STP on
MAC
one of the
address
switches.
unstable. Yes. Okay. Again.
Can we enable STP on one switch?
Yes. Let's see. Now it come to 75,000. Okay.
Wow.
Okay. Let me go to S2 and STP enable. Yes. STP enable. Now I only enable STP in one switch. Oops. Then it stopped. Okay.
Yeah.
The broadcast stop is stopped.
So that means it's discarding some of the broadcast there. Okay. Right. Discarding some of the forwarded.
Let's see. Display STP brief. What happened? Learning. What happened? Not yet, because it's learning state. Later we see. Will it continue to forward? Okay, now it's forwarding. Let's see. Check. Wireshark. Is it doing anything? Oh, okay. I continue to think again. Okay, continue non-stop. Continue non-stop. Because all the ports are forwarding state. 1, 3, 4, all forwarding state. Just like don't have STP at all.
Yeah.
Forwarding state. So do you need another one? Do you need another one?
The switches have to be, all the switches have to be.
Yes, all the switches must have STP enabled. Yes. Okay.
You have to ping again?
And but you still cannot ping yet because let's say S3 display STP brief. It's still learning state. This is some transition states of STP when STP network is converging. Later we also will learn this. What are these? So it takes some time. You see, want to enable a STP also takes some time. Okay.
Yeah.
Between that time, that period, your network is disconnected. Now it's all forwarding here. Here, just now we saw one, right? The G3 is blocked. Yes, discarding state. So this is the stable state, already converged, done converge, discarding. Yeah. So G3 is blocked.
Yeah.
So no traffic, no frame will be passing through this link. No traffic. Okay.
Yeah, that makes sense.
Okay. So now this is blocked. G3 is blocked. What happened? What if? What did I say? Let me take a router.
It's breaking the cycle now.
It's breaking the cycle, but what happened? If here. What happened? Let's say my router is connected to the internet. My router is connected to internet. I block this. What happened? All the traffic go this way.
Routed through S2?
To the router. Because they want to go to the internet. Correct. Is this traffic flow correct?
No, with the router, it should be able to come through G3 on F1.
Okay, this port is being blocked by the STP. So all the traffic will go through traffic from PC1. If I want to go to the internet, let's say router assemble the internet. Okay.
Through G1 on S2.
But this is a traffic flow, correct?
Yeah.
From PC1. PC2, this way.
Yeah.
Same. Okay. What happened at this port?
Congestion.
Is it congestion?
Yeah.
Okay. Why not I block this? Why can't I block this one? Is it better?
Mm-hmm.
No, but if you are running, something like OSPF on the router, you should be fine.
So OSPF on the router should be fine. No, I mean the suboptimal path. I mean, you want this, yeah. You want this, or you want everyone to go through S2 and then go to S1, or you would prefer this?
This is better.
This is better. Yes, it reduces the congestion at only one port rather than just everything go to one port.
Yes.
Yes, this is better. So, but the what happened now is the S1 G3 is being blocked. Can I change this? Can I change this? Yeah, I can change it by manipulating
Yes, you can
something.
change it.
Yes, this is what we want to learn. Huh? We learn the concept of STP is for us to decide. So we can manipulate which port to be blocked. I can exactly control. I want G2, S1, G2 to be blocked. I want S2, G1 to be blocked. One of the port to be blocked. Which one? I can exactly configure that. I can do that. Okay. So, okay. And we
So we
go
have
to
to,
the,
Mr. Bay.
yes.
So that means we have to undo shutdown on S1, G3.
S1, G3, and no. See?
We don't have to undo
The
shutdown.
port
No?
is up. The port is active. The port is up.
Exactly. It's from the spanning tree that it was shut down.
Interface brief. You see? G3 is up. G3 is up.
Okay. And I mean, if
G3 is up.
it was blocked before you did the spanning tree.
Display STP brief. If I don't have spanning tree, means if you want to stop the flood, stop the broadcast storm, you have to shut down one port. Okay. Now STP, what you do? Discard all frame. Discard all the frame that coming into G3.
Okay.
Or coming out or going in, whatever. No frame can passing through G3 at all. Okay. So when this link down, let's see. When this link down, I remove this link. We check the S1. I display STP brief again. Now G3 become forwarding.
Okay.
Okay. So this automatically because of this STP technology.
Right.
Okay. So since this broadcast storm is so easy to happen, so that's why for all switch in the market, the STP is enabled by default.
Okay.
Because this spanning tree is very, very important, very critical. Okay. So we connect this back.
So Mr. Bing.
Yes.
So supposing one of the switches has a problem, how do you know which one should be the controlling switch in the network?
I mean, which one? How I decide which port to be blocked? You mean?
Yeah, I mean if the switches have sort of are we saying that all of them are like in terms of priority, all of them are the same when it comes to forwarding and discarding packets?
Yes. Okay. Okay.
Yes.
This is what I want to teach. Okay. Let's go into the slide. Okay. Okay. Spanning tree protocol. So as the enterprise network expand, multi-switch network are introduced to providing layer communication between growing number of end systems. Because in one network, you might have many devices, more and more devices you want to connect to the same network. Okay. So as a new interconnection are formed between multiple enterprise switches, new opportunities to forever resilient network are made possible. Resilient means when something happens, the network can recover very quickly. Okay. However, the potential for switching failure as a result of loops become ever more likely. It is necessary that the spanning tree protocol therefore be understood in terms of behavior in preventing switching loops. Okay. So just now I already described the first one, issue faced when using a multi-switch network. And then I will explain how spanning tree protocol converge to prevent the loop. And then I will teach you how to configure parameters to manage the SDP network design. Means how to decide, how to manipulate which port to be blocked. Called layer 2 redundancy. This is redundancy in switching network. Minimize connection failure but generate potential loops. Okay, 3 switch connect to interconnected can generate loops. These have more switches are interconnected. So even though only 2 switches with 2 links connected also can generate loops. Okay, 2 switch, 2 link also redundancy also have a loop. So in layer 2 network, once you see redundancy, if you don't have SDP, you will sure have loops, sure have broadcast stop. Okay, so this is a broadcast stop I showed you just now, and then this is a MAC address table instability, key on update non-stop. And then to resolve the issue, just block one of the ports. So we will learn how SDP will block one of the port, how SDP decide which port to be blocked, and how we can manipulate it. Okay, the spanning tree root bridge, and here, an inverted tree architecture is created as a result of SDP. The root bridge represent the base of the spanning tree. Okay, so in one broadcast domain, in one network, everyone running SDP. So all the switch will run the election to elect the root bridge. The bridge that here also you can call it root switch. Okay, root switch, also the same meaning. Okay, so one of the switch will become the root switch. But in this topic, I just call it root bridge. But you have to know, I also mean that the bridge is a switch. Okay, the root bridge, in one SDP or in one network, only one root. The other we call non-root. Okay, that's all. So how the root bridge is being elected is based on the bridge ID. So what is the bridge ID? The bridge ID is the combination of bridge priority and the MAC address. Okay, bridge priority and the MAC address. So okay, so you can see this in this architecture. This is a root, but not necessarily this is the root. This also can be the root. This also can be the root. This also can be the root. So everyone, all the switch in the same broadcast domain will join the election. And one of the switch will be selected as the root. So how the root is being selected? It's based on the bridge ID. Bridge ID, again, is bridge ID in combination of bridge priority. By default, the bridge priority is 32768. And then the behind is the MAC address. MAC address, you cannot change because it's the switch own MAC address. Is universal unique. You cannot change it also. What you can change is this bridge priority. That's why below here as a statement, the bridge priority can be manipulated to force root selections. Okay, so how to do it? The lower the bridge priority, okay, I just made this segment is better. The switch with the lowest bridge priority will become the root. Okay. So this is 4096. We can configure 4096. All the other switch remain at 32768 by default. So automatically this is the root. Okay. So I go back to my S1. Okay. Yes.
So what's the how many bits is the bridge ID?
How many bits is the bridge ID? here, let me show you spanning tree protocol. Bridge ID, bridge ID. This is the bridge ID. How many bit you think? Okay, this is the bridge ID.
Because the max is already 48, right? So
this is behind is a man. The bridge ID is 4 times 4, 16 bit.
So that makes 64-bit wide, both the ID and the MAC.
Again? Sorry, again?
Is that correct?
Again? What, pardon?
I mean, the MAC and the ID form together, I mean, combined together makes 64-bit, is that correct?
To make a 64-bit, 48 plus 16. Isn't that 16? 48 bits. 48 bits plus 16. 54 bits.
Yeah, just in case
60,
the question.
60.
Just in case there's an example.
Yes. Correct. Okay. But in the exam, they will ask the bridge ID, the bridge priority.
Okay.
60 bit for bridge priority. Okay. So for S1, so now display SDP, we try to check. Now the mode is MSDP, running MSDP. So there are several SDP we can run. SDP mode, question mark. In Huawei switches, we support this. SDP, this is the legacy, the very first SDP. Okay. Then this is the enhanced version. Because the legacy one is very slow, so we enhance rapid SDP, and then we further enhance multiple SDP. Okay, so now by default is running the best one. MSDP is the best for in this switch. So SDP mode SDP, I change this to SDP also. Okay, so S2. System view, SDP mode, SDP. System view, SDP mode, SDP. Display SDP. Yes, already changed to SDP. Okay, but regardless, whichever mode you change, display, SDP brief, S1, G3 is still the port being blocked. Okay, alternate port. Okay. And then let's see. Now I want the port being blocked is either S2 G3 or S3 G2. So what I can do is I make the S1 become the root. Let's see. SDP priority question mark 0 until 61440. By default is 32768. So the lowest one will become the root bridge. Put it 0. Now I display SDP.
Sorry, but the default SDP priority number is what you said.
The default bridge priority is 32768.
Okay, thank you.
Yeah. So display SDP brief learning. So how do you check the bridge ID of the switch? Okay. Now forwarding already done. You see now S1 both are forwarding. Okay, how to check the bridge priority, the bridge ID? Same, display SDP brief. No, display SDP, enter, and then this one. HCIA this global info. This is CISC. All this CISC is the information in the MSDP. Okay, But now we are looking at the mode STP mode. CISD bridge is the bridge ID of the switch, this one. Now, just now I changed the priority to 0, right? 0 dot, this is the MAC address of S1. So this is also the thing that I copy and paste it here. Okay. So now I change this to 0. So S1 is the root. This one is the root. So I see that display STP brief. STP brief forwarding. Okay, you can see the port row. Designated port, designated port. Okay, I can just label it here. Designated port. Designated port. S2, display STP brief. Okay, root ports. This is a root port. This is the designated port. This is the designated port. So both all the root port and designated port are forwarding state. Final state is forwarding. So I can tell you that this is a designated port. This is the root port. This is the alternate port. Okay, you don't believe I can here. S3 G2 alternate. Display STP brief. Okay, again. Display STP brief. S2 S3 G2 alternate ports discarding state. All the other two ports are root port forwarding, designated port forwarding. So this is the one being blocked. G2 is blocked. So you can see that all the switch that being elected as the root bridge, all the port is always designated ports and
Mr.
always forwarding. Yes.
I'm a bit curious as to why on S3 we have the root designated and alternate, while on S2 we have root designated and designated again. Why not alternate as one of them?
Because we only need to block one port.
Okay, because of the connection between S2 and S3, right? One is already alternate. Okay.
Yes, I only need to block one port. Okay. It's enough. Okay. Yeah, so let's continue to learn. So now you know how to elect the root bridge, right? Okay. Then next, go to the next one. So this bridge ID, I already tell you, you can manipulate the bridge priorities so that you can force the election of the roots. So actually in the live network, we always put our core switch as the root bridge. Because we never know, because everyone starting the default is 32768. The MAC, because if everyone the MAC address, if the bridge priority is the same, then they will compare the MAC address. The switch with the lowest MAC address will become the root bridge. So in live network, your core switch, the MAC address of your core switch might be lower, might be higher than the MAC address of your access switch. So in order to make sure the core switch is the root, we change the bridge priority of the core switch to 0.
So Mr. Wei,
yes.
So it seems one has to search through to find out the IDs of each one first before you begin to talk about which one to elect. Is there no way one can just determine, or declare a root, a root switch?
Again. Sorry, again. I don't.
I mean, is there no way one can just determine a root switch? I mean, by either a command or something.
Determine the root. Yes, there is. One of this is the command actually. STP root primary. That's all. So this will be the. But what this primary do is display STP. Again, it just change the bridge priority to 0. That's all.
Okay.
Okay. It's the same method. That's what. But the difference, if you apply this root using the STP root primary, if I try to change the priority to others, let's say 4096, it's not allowed. Cannot be changed. Okay, this is a difference. Okay, now everyone know how to elect the root bridge. Anyone can be the root bridge as long as he has the lowest bridge priority. If the bridge priority is the same, then only compare the net address. Okay, next. So just now I changed the root, change the bridge priority of S1 to 0. But how the other routes, how the other switch know that, oh, the S1 bridge priority is the lowest one, he is the root. How they know? That's why we have this protocol data unit, bridge protocol data unit. All the switch send each other bridge BPDU, we call it BPDU, to each other to negotiate, so that they tell you that what is my bridge ID. So I send to everyone also send to me. And I can know, okay, negotiate, I can compare until the end. Okay, we know that who is the best. Okay, for BPDU, we have two types of BPDU. One we call configuration BPDU, and the other one we call TCN BPDU. Okay, as you see, this is the example of the, no, this stop already. I open another one for you to see. Let's see at the S1 G2. Okay, you can see S1 is keep on sending the spanning tree, the configuration BPDUs, yeah, CONF. I open the link here. BPDU type configuration. This is a configuration BPDU. So we start from the link there. This is what format? IEEE 802.3 format. And then source form, this is S1 MAC address. Because this frame is sent by the S1. Destination to spanning tree multicast MAC address. This is the multicast MAC address. You see, 0, 1. 1 means 0, 0, 0, 1. The big number 8 is 1. So this is a multicast MAC address. Multicast to who? To all the switch that running STP. So it means that all the switch receive this, they see this. All the switch running the STP will receive this and check, okay, oh, this is for STP switch. So they will accept and process. Okay. So this MAC address, please remember this, memorize this. This will be asked in the exam. Okay, 01 X0 C2 0000000. Okay, this link logical link. You just can look at this SSAP. Let's look at this type 3. Remember type 3. Okay. You can say this is the ether type 3. Okay. Just like the ether 2 frame, ether 2 header. Okay, so here length, the length also less than 1500. So this is the IEEE 802.3 format. Okay, next one. So the important is this, spanning tree protocol header. So protocol identifier, PID. This is a spanning tree protocol. Okay, and the version of this ID, version ID. Version of spanning tree is STP. Just now we can see that the spanning tree protocol is a protocol. It's a big name of the protocol. Under this protocol, we have several versions. The most legacy one, the name is the same, STP. Enhanced RSTP, and then you improve again, MSTP. This is a version ID, 0 for STP. And then BPU type, only for STP, the most legacy one, they have the configuration BPDU and the TCN BPU. This is the how configuration BPDU looks like. So configuration BPDU and then the flag, two bits, only 2 bits under the flag, 2 bits is using topology change acknowledgement, TCA and TC topology change, 0 or 1, 0 or 1, only 2 bits. And then root identifier. This is to tell who is the root in this network. So this root identifier will keep the bridge ID of the root. That means 0, and then MAC address of S1. The root path cost. Okay, what do you mean by root path cost is the cost for the sender of the sender of the BPDU or the configuration BPDU to go back to the root. Okay, who sent this BPDU? S1 sent this BPDU, and S1 is the root. So what is the cost for the root go back to himself? 0. Okay, and then this is the bridge ID of the sender of this BPDU. So this bridge is sent out by S1. So this is the bridge ID of S1. And then port identifier, PID. Okay, later we'll see. The PID is the combination of port priority. By default is 128 with plus the port number. Okay. Then we have the message age. So this is sent out from S1, the roots. So the message age is 0. Then when it sent to the S2, it becomes 1. Okay. And then message 20. This message age can go up to maximum 20. And then the hello time, 2 seconds, is a time that the root send the BPDU. See, 27, 29, 31, 33, 35, 37. Every 2 seconds, send out a BPDU. Every 2 seconds. Hello time. For delay is for the state transition. Just now you see the state, learning, discarding state, learning state, forwarding state. All this. This is the transition, state transition delay. Okay, so this is the bridge ID. TCN is a bit different. Later we'll see how TCN looks like. So the root will keep on sending BPDU. Okay, the root send one BPDU to this switch. This switch will change what? Change the bridge ID. Okay, change the bridge ID, and the port ID, message age, everything is related to his own, the bridge ID to his own BPDU. Actually, you cannot say it's change the bridge, change the frame sent by the root. Okay. Okay, now the root send the BPDU. The switch receive, then he takes some information. Important information is this: who is the root, and what is the root path cost, and what is the message age. Okay, these three. Take this. The most important is the root ID. Okay, root ID, and then this switch will generate a new configuration BPDU and include the root ID you get from the first BPDU, because you need to send the BPDU to tell the downstream switch who is the root. So you can see that the root will send BPDU out from his designated port to everyone, to his downstream switch, every 2 seconds to remind them who is the root. S1 is the root. Okay. So after deciding the roots, then we need to decide what the port rows. Okay, remember we have 3 port rows: designated port, root port, and alternate port. How they decide who is designated port, who is root port, who is alternate port? Okay. The first and foremost, all the ports on the root is designated port. Confirm. Okay, confirm designated port. So this is designated port, designated port. Okay. Before this, before we learn how they decide, we learn what is path cost. Path cost. Path cost is the cost of every port. Let's say if this port is 1G port, means that this port is 20,000. This port also G port, 1G port also 20,000. Let's say this port also 20,000. Okay, path cost. This is the standard table. Okay, for all the port speed, 10 meg. Again, let's see the standard first. 802.1D, 802.1T, and path cost legacy. This is very legacy now. No one using this. Huawei switches are using 802.1T by default. Cisco switch are using 802.1D by default. Okay, and then what the similarity at here is, the higher the port speed, the lower the cost. 10 meg, 90. Let's say I follow the Huawei one. 10 meg, 1,999,999. 100 meg, 199,999. 1 gig, 1G, 20,000. 10 G, 2,000. If I have 40G, 100G, will be lower. 200, 20, like that, lower. So means that the faster the speed, the port speed, the lower the cost. Means the better it is. Okay. Okay, I can understand this. So what is root path cost? Now we want to learn what is root path cost. Because the root path cost enable port rows to be determined. Okay, so the root path cost is the cost that for the switch to go back to the root. Okay, the shortest path or mean the lowest cost path to reach the root. Okay, so for the roots, again, for the roots, what is the root path cost of the root? What is the cost for the root to go back to the root? 0. That's why when the BPDU sending out from the root, the root path cost is 0. 0. Okay, next one. Then let's say this switch, this switch receive this BPDU. Inside the BPDU, it will show that the root ID is this switch bridge ID. So then he know that from this way, the root path cost is 0. If I go out to this way, the root path cost is 0 plus my own port. This one, 20,000 plus 0. So my root path cost is 20,000. So I send the BPDU to tell my downstream switch, tell him, okay, my root path cost is 20,000. I also send out from this port, tell this direction. I don't know how many switches is there, but I don't care. I just send. I tell this switch, next switch, my root path cost is 20,000. Similarly, for this switch, you also receive from the root. You receive, you know that this switch, I receive a root path cost 0, and then I add with this port. My port is G port, 1G port, so 20,000. So 20,000 plus 0. So means that if this switch go this way, if take this way to go back to the root, the cost will be 20,000. So that's why he tell the other switch, the downstream switch, my root path cost is 20,000. My root path cost is 20,000. He tell downstream switch. Okay, so between this and this switch, they tell each other, my root path cost is 20,000. Tell each other, my root path cost is 20,000. Okay, like this, huh? Okay, so how can the root path cost enable the port row to be determined? So, okay, so the port that is nearest to the root is the root port. Understand? Okay, how to calculate? Let's say this switch send the BPDU to tell this switch root path cost is 20,000, correct? So this switch receive this BPDU 20,000, then he add with its own port 20,000, total 40,000. Okay, then this switch will know that, oh, I see. If I go this way, it's 20,000. If I go this way, it's 40,000. Okay, then I know that this is the better way, better path. So that's why I make this my root port. Root port is the shortest path. You can say the lowest cost path back to the root. So all the non-root switch only have one maximum and must have one. Must have and maximum one root port. Okay. So what's next? Next one, okay. This already has a root port. This one has a root port. Next one, they need to decide. Okay, this is my root port. So means that only one root port. All the other ports are either might be designated port or alternate ports. Designated port or alternate port. So between these two switch, how they decide this and this? Who is designated port? Who is alternate port? So the first one they compare is by comparing the root path cost, the sequence. They still comparing the root path cost, but both sides tell each other, my root path cost is 20,000. My root path cost also 20,000. Same. Cannot. We need a tiebreaker. So we compare. Yes.
Sir?
Yes. Okay, now it's already 9
Solomon.
PM. Okay.
Okay, Solo. Good afternoon, Japan.
Hello.
Yeah.
Please, Godson. You need to mute your microphone, please.
Okay, I mute him. Okay. Okay. So both sides, two switch. Yeah. Root path cost is the same, so cannot decide. So they move on, compare the next one. They compare the bridge ID. So the bridge ID also can be used to decide the port row. So who have the better bridge ID? Better means who has the lowest bridge ID. Bridge ID, if both sides is by default the bridge priority 32768, then they compare the MAC address. Who have the lowest MAC address? The lowest one will become the designated port. The higher one will become the alternate port being blocked. Okay.
No.
So how about this side? So this side is very easy. Who is the D? Who is the R? Okay. Why this switch pick this as R? Because there only one path that can go back to the root. Only one path. So this is my root port. Okay. So you can also say that because this is the only path that this switch can receive the BPDU. Also can. You also can compare. Okay, this switch tell this switch my root path cost is 20,000. Then what this switch do? They take this 20,000, add this port 20,000, 40,000. So this switch is 40,000. This switch is 20,000. So this switch is better. So he is the designated port. Me, because this is the only path. I don't have any other path anymore. This is the path that has the lowest cost back to the root. So this is my root port. Actually, for the topology, you already can see if this is the only path back to the root, this confirm is the root port. Okay, this is root port. The other side must be designated port. Okay, designated port is a port that send BPDU, send the configuration BPDU, send, then also send, and then this is designated port, send BPDU to tell this switch, to tell this port. Why? To tell I am better than you. I have a better bridge ID than you. You must remain as the alternate port. Okay. So this is also a port. Alternate port is also later we'll see another thing. So this is how the bridge planning port rows. The port row is being decided. But what about the port ID? Port ID, how the port ID is being used. You see, this is a root 4096. Now this is a root. These two switch, okay, have two link connection together, connect together. So again, if there is a redundant, there will be a loop. So one of the port must be blocked. Which one? Either one will be blocked. So for the root, all three ports are designated port. Okay, as what we have learned. So this port, these two ports will send out BPDU, configuration BPDU. Inside BPDU, the root path cost is 0. Received by this switch. So this switch, how he decide? Okay, both paths, same cost. This is 1G port, this is also 1G port. Both paths are 20,000. How you decide? I cannot decide. So I compare the bridge ID. Compare with who? I compare the bridge ID inside the BPDU. Okay. Who is the sender of this BPDU? Root. Means that the bridge ID in these two BPDU is the same. It's the same. So I cannot compare. So I move to the next one. This is where the port ID is being used. I compare the port ID in these two BPDU. So port ID is the combination of port priority and port ID or the port number. Okay. So by default, port priority is 128. So depends on, see, this is the 128. Okay. So depends if this port priority is maybe 0. So the 0 is become the root port. Then the other one is the alternate port must be blocked to be blocked. Okay. So what if both sides port priority by default 128, you don't change anything, so so you have to compare the port ID. Why? Because the port ID, port number of the switch confirm different, won't be the same. Okay, so still look back into the BPDU. The port with the lowest port number will become the root port. The other one, alternate port. Again, this BPDU, this is also the BPDU sent by the root. This switch take these two BPDU and compare the port priority 128, 128. Okay, cannot decide. Compare the port number. This is 1. This is 2. I know that this one is better. So this is my root port. The other port is the alternate port. Okay, so how to decide? Maybe this should be this, because if you look at you compare whatever at the sender side, not the switch own port number. No, remember, compare the sender side. This should be port number 1, port number 2 on these two ports. This is 1, this is 2. So you know that this is group port. This is alternate port. Then this is being blocked. So for the others here, these two, okay, then I know that this how this is being decided based on the root part cost. Because here send out 0 plus 20,000 20,000. So send out from here should be 20,000 20,000 plus 20,000 40,000. So this is the root port. This is the alternate port. Okay. Again, okay. Why this is designated? Why is alternate? It's because both sides have the same root part cost 20,000. Then they compare the bridge priority, same, and then MAC address 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. This is BB, this is CC. BB is lower, smaller. So BB become the root designated port. CC become the alternate port. Okay. So next one, the timer. Again, I already told you the timer is to tell you, okay, every 2 seconds, root will send a BPD. Keep on telling, constantly telling all the switch who is the root. Okay. So when the BPDU send out from the root, send out the message H is 0. When come to the next switch send out, it becomes 1. Next switch send out, it becomes 2. It keep on increase until 20 and then 21. When the switch number, maybe number 1, 2, 3, 4, 5, 6, and 20, 21, switch 22, he will receive a message H 21, max H 20. So he will discard the switch, discard the BPDU. So that switch will not join the election, will not join into this the STP network. But impossible, it's not practical you met that situation because you have to consecutively cascade 22 switch in one line. Impossible. There's no such design, never designed in live production network. Okay. So all the non-root switch will send BPDU only when he's received the 1 BPDU from the root. So root send 1, then only this switch send 1. Then only this switch send 1. They have to wait for the upstream. I receive 1, I send 1. I receive 1, I send 1. Okay. Next, this is the root election process again. We've been through this. So at the beginning, all the ports, all the switch, they don't know each other. So they tell each other, I am the root, I am the roots. They send BPDU to each other to tell each other what is my bridge ID, so that they can make comparison. So in the end, they know that switch A is the root, and then switch A will keep on telling, oh, my root part cost is 0. So they compare. This is the root port. See, this is the root port. Root port. Between here, they compare. Okay, for switch C, 20,000. So this port is 20,000. For switch B, also the same. This port is 20,000. So they got same root part cost. So they compare their bridge ID. 32768, 32768. 00E0 FC4142. This is 42. This is 43. So this is better. This is the designated port. This is the alternate port block. Okay. So next one, port state transitions. Okay. So at the beginning, everyone is disabled. Means that STP is disabled. Okay. And then when everyone is stuck, STP enable, or the port is active, going up, I connect the port. The port is become the blocking state. When blocking state, the port will not send BPDU. It will keep on waiting. Wait how long? Wait for the max H, 20 seconds. Okay, wait for 20 seconds. Means that in this election process, where everyone start SDP enable, everyone, all the ports are designated ports, because there's designated port and blocking state. So they hold, they doesn't do anything. It's just waiting. So, but they will receive BPDU. They're waiting for BPDU, but nobody send it. So after 20 seconds, everyone will start to send BPDU to each other through their designated port. So after 20 seconds, everyone start to send BPDU. Is when they go into listening state. In listening state, everyone start to send BPDU. This is where the election is ongoing. Listening state, they run election to select the root bridge and then decide the port row. After they decide the port row, our alternate ports will go back. Okay, will will change to blocking ports. Okay, then all the designated port and root port will go to learning state. Okay, how much time is being given to run the election and decide the port rows? 15 seconds forward delay. From here to here. Okay. Okay, 15 seconds forward delay. Learning state is to learn MAC address to populate the MAC address table. In learning state, because all the end device is keep on sending frame, so all the ports will start to learn MAC address. Yes, learn MAC address.
Mr. Bell?
Yes.
Just two questions quickly. When are we closing? And then second one is to move from the blocking state to from the listening state is how many seconds you said?
20 seconds. Yeah, 20 seconds.
And then listening to learning is
15 seconds. Because they run election and decide the port row, they need some time, right? The 15 seconds is being given to run the election and decide the port row. Okay. After that, learning state. Designated port and root port learn MAC address. They fill out their MAC address table. How much time is being given to learn? Also 15 seconds for delay. Okay. After that, designated port and root port will become forwarding. So start to forward user traffic. Alternate port stay at blocking. So forwarding and blocking is the final state. All these disable learning and listening are just transition state. Okay. So, but you can see all the ports can go back to disable anytime when the SDP is disabled or the administrator shut down the port. Disable. Okay. Okay. So this is about the root failure. I think we talk about this tomorrow because now it's already 9:17. At least this is the after this state, everything is forwarding, and then alternate port go to blocking, all stable. And SDP network is converged, stable, done. Okay. Tomorrow I will go into if there is any root failure or anything, something odd happen, something fails, how the SDP will react. This I will talk tomorrow. Cool. So until here for today. Okay. So you have to remember how the root election is done. Okay. So again, so I repeat again. Well, after all, how the process of the SDP network to converge is first decide elect the root bridge. First step, elect the root bridge. Second step, decide the port row. Okay, and then done. That's all. after this, of course, you have to decide how to elect the row bridge. Is based on the bridge ID. The bridge ID, the switch with the lowest bridge ID is the root. So first they compare in bridge ID. First they compare the bridge priority. If both the switch with the lowest bridge priority will become the root. If both bridge priority is the same, they compare the MAC address. The lowest MAC address will become the root. After that, they manage to go, after they elect the root, then they decide the port row. Okay, all the port rows on the root are designated port, confirm. And then for downstream switch, first they compare the root path cost. Okay, the lowest root path cost, the port with the lowest root path cost will be the root ports. Okay, root ports is this one. And then when you want to decide who is designated port, who is alternate port, also first one they compare the root path cost. Who have the switch with the lowest root path cost will become the designated port. The other side is the alternate port. If both sides have the same root path cost, they compare the bridge ID. Okay, if comparing the bridge ID, still the same method. Lowest bridge priority will become the designated port. Okay, and this one link, if only one link, one-to-one, only one link. If two link, compare the port ID. Same port priority, 128, 128, compare the port number, confirm different. Okay. Okay. After that, everything is stable. Then tomorrow I will explain the special situation like root failure. Okay. So until today, so a little bit recap. So today we've been through the navigating the CLI to BRP, still remember. Then we do the file system navigation. We create a folder, we delete the folder, and we copy a file, we move a file, we rename a file. And then after that, we go into we learn how the router, how the network device can connect to the FTP server to back up their configuration file or their log file and download the latest, the updated system software image. And then we learn the single switch network. Okay, how the switch behave to frame, either to unicast frame and broadcast frame. Okay, and today let me show you the picture again. So this one, all this, please remember this. Okay. Okay, and then we go into this spanning tree. Why would we have spanning tree? Because when the layer 2 switch interconnected together, they will have redundancy. Redundancy is good, but without the redundancy cause loops, which will cause the broadcast storm, MAC address table instability, and also the end devices we keep on receiving the duplicate frames. Okay, and then so this issue, so we introduce SDP, spanning tree protocol, to logically block one of the ports, or I should mean to logically block the redundant link. And then if the active link is down, the redundant link will up automatically. Okay, so this is the SDP technology. Okay, so that's all for today. Okay, is Jeff here? Okay, do you have any questions? So I hope you can take some time to digest what I have told you today. Okay, and then we continue tomorrow. Same tomorrow. Yes, okay. tomorrow after we finish the topic of the RSTP, we also will go to some of the questions for you to test the understanding on the SCP. Okay.
Thank you very much.
Okay, thank you. So the class today ends here. So if you don't have any other questions, you may leave the meeting. Okay.
It's all right. Bye.
Okay. Goodbye. Have a nice day. Okay. Okay.
Have a nice day.
Okay.
White. Bye.
All right. Good night. Have a good
Okay.
have a good day. Oh, is that good night over there? Yeah.
Good night. Yeah.
Yes,
now
good night.
I'm already 9:24 p.m.
All right.
Okay.
All right.
Good night. Good night, Jeff.
Okay. Good
Good
night.
night.
Good night. Hey, level.
Good night. Thank you.
Okay, see you.
Thank you. See you tomorrow.
See you.
Yeah, same time.
Bye-bye.
Okay.
陈曦老师，你那个问题整理的话，你明天整理也可以。学问题整理，明天也可以。到时候e-space 发我就。拜拜。
OK，行。拜，穆萨。
因为就是我明天调休，正常的话，明天还是会上午把日报和什么日报，我想想，日报和出勤都会发出来的。啊，对，我忘抄你了，我忘发给你了。哦，行，我明天我把那个日报还有出勤都发给你。
好，行。
差不多明天上午9点半之前给我就可以，不是很急。
OK。
今天晚上就不用加班。
好，谢谢哦。
行，没事，已经太晚了，今天。
是9点。
拜拜。
好，没什么事，那就明天见。